Hello and welcome to this Terraform with AWS full course by Mindmajix. As companies rapidly move to the cloud, managing infrastructure efficiently has become more important than ever. That's where Terraform comes in. Terraform is one of the most widely used infrastructure as code tools that allow you to define, provision, and manage cloud infrastructure in a constant and automated way. When combined with AWS, Terraform make it easier for teams to build scalable, secure, and cost-effective cloud environments. Instead of manually setting up servers, networks, or databases, with Terraform you can write simple configuration files and deploy in minutes. In this full course, we will cover everything from Terraform basics, providers and modules to deploying infrastructure on AWS, managing states, variables, automation, and more. Organizations of all sizes, from startups to Fortune 500 companies, are adopting IAC for faster delivery and reduced errors. In India, professionals skilled in Terraform with AWS, such as DevOps engineer, cloud engineers, and SREs, earn on average between 8 to 20 lakh rupees per annum in India, depending on their experience. Adding certifications like HashiCorp Certified Terraform Associate or AWS Certified Solution Architect can further strengthen your profile and open up high-paying job opportunities. And if you want to learn paid Terraform with AWS course with certification, then check out our course, where we will provide latest industry curriculum, hands-on projects, labs, mock interviews, and more. Before moving ahead, I want you guys to like, share, and subscribe to our channel so you never miss any tutorials and courses from us. Now, let's dive in with our Terraform with AWS full course.
Okay, I have a AWS instance, AWS console login. Okay, so where we can see all the services. Okay, so it will provide compute-based services and storage-based services and container-based, database, right? So we have all these kind of management-related services, right? So all these services we can able to we can able to create it, right? So see here, if we want to create some instance, we can go with this particular service, EC2 instance, right? Likewise, we can have containers, and if we want to kind of S3 storage and database, everything we can able to create it on our own manual stuff. Manually, we go here, EC2 instance. I just click here, EC2 instance. Basically, infrastructure is like how it is. Like I need a kind of set of machines, and those machines I need to install something, and I'll be having a web server. I need a kind of database, and in between I need some messaging servers. All these things has to be connected, and in between I need to configure these servers by deploying some services inside it, and I'll be enabling porting and applying the security patches, security groups, and opening ports, right? And the route table configuration. So everything, all these things we'll be doing it manually. So this all together it's infrastructure, right? So that's how we'll be constructing an infrastructure. Like we'll be having some server here, web server will be here, and will be having a, so this may be some server, and the server internally calls some what is that messaging services, and that internally called some databases, right? From the database again we'll be having some kind of what is that calling another service, another instance, right? So think about this perspective. So all these things, right? So we have to name it for each and every services, and we have to assign the port number, and we have to kind of apply the security patches, and the kind of routing tables, all rules, policies, right? Roles. So everything we need to assign it, then only we can able to establish this particular communication. So this we have been doing it manually a kind of 10 years before, right? So before the kind of infrastructure and automation, before that we are doing it manually. Either way, like we'll be doing some part of it in the programmatic way, like assigning the ports, assigning the names and the IP address range, right? The site annotation, all kind of the subnets, and creating the VPCs. We have to put all these things in the VPC. This is one subnet, this will be the other subnet, all together will be the kind of single VPC, right? And if we want to create some NAT gateway or internet gateway, so all these things, right? We can able to kind of create it in a manual way. That's how we structure. That's how we created infrastructure before. Now we have to make use of it in the automated way. Okay, so why we go for automated? Assume that we have created an entire stuff. We spend lot of time and created this infrastructure in AWS. In later, I want to migrate from all this whole infrastructure from AWS to Azure. I cannot I cannot sit again. I cannot spend the same similar set of what the same volume of time whatever I spend for AWS. I cannot spend again for Azure the same thing. I should it should be able to, it should be kind of available in the code level so that I can do in the minimal changes. Okay, and with that small change, so entire infrastructure has to be kind of migrated. This is one of the way. Or same AWS itself, I want to change something like instead of this particular database, I want to change it as from MySQL to Mongo. I want to change it. Okay, MySQL to Mongo. So just for this particular change, I don't want to kind of disturb the entire stuff. Okay, only this particular stuff I can able to change it like that. So Terraform will be maintaining, okay, our the code will be maintaining its history, and the set of blocks will help us the declarative way how we are going to approach this particular code. Okay, so that will be kind of make our life easier. Okay. um, Later if we want to kind of maintain this particular code, okay, in the next version, so those things we can able to upgrade. Even MongoDB is there, I want to upgrade this particular version from version 1 to version 2. Okay, that also easily possible. Backward compatibility, how this particular thing will be communicate with other services, right? All these things we can able to make. So everything we have been doing it in the manual way, now we are doing it in the code way, because it will be kind of easy to kind of reusable. Okay, in future we can able to reuse it. Okay, for example, here let me create one instance so that okay, so we have one instance. Let me launch the instance. So just we'll go with the steps. Okay, okay, I'm just going to create one instance. Okay, manually I'm doing it. Now you see test. I named it and I want to create a Ubuntu image. Okay, Ubuntu as a OS, and that will be the Amazon machine image AMI. Okay, let me choose maybe free tier. Okay, so 20.04. Okay, I'll be using this. So this particular image, right, Ubuntu server. So this is human readable form, right? So same thing, it has its own image, that is image ID, that is AMI. Okay, Amazon machine image, so that has some number. See, 1B5612, right? It has some number. So if we take this particular image ID, that will refer this particular name, whatever. So each and every what is that version of this particular image will be having the image ID, the separate image ID. Okay, so Amazon what is it, AMI will be having the separate image ID. Like if you are purchasing a laptop, right? So on top of it's a hardware, right? On top of the hardware will be, we have to install some OS, right? So that is OS. Okay, I just choose this. Okay, for example, so it's a free tier, so I'm just using this particular stuff. So in case if you don't have this account, right, AWS account, you just create one so that you can able to kind of play around in the Terraform. Okay. Okay, so simple. First thing is I just named it as this particular stuff, and I choose the AMI image and instance type, how big it is. Okay, what is the kind of how many CPUs, what is the memory. So based on that, we can able to choose the instance type for it. Instance means we are creating some virtual machine. Okay. So rest of the things are similar. Okay. Some as it is, leave it for now. So going forward, we'll incrementally add all these things. Okay. We'll be doing it in the, maybe I'll choose existing security groups. We'll choose default. Okay. So yeah, let me launch it with the minimal settings. Okay, I need to choose the keypad. Let me choose it. Just launch it. Okay, to launch any instance, right? What we need, just need to AMI. AMI is first prepared option. We need AMI machine image. Then we have to give the instance type. Instance type. We are going to create an instance. So for that we need AMI instance type. And what else? We need a key. right? Some key to connect SSH key, right? So SSH key, and what else we choose? That's all. So these are the very minimal requirement, minimal parameters required for any instance to run to reach the particular stuff, right? So, okay. Now the instance is up and running. Now let me go here. Okay. Okay, whatever we are given, see instance is running. Okay, so this is the instance ID. This instance ID is different, image ID is different. Okay, so instance ID is the one which will be assigning ID for that particular instance. We are giving name here, right? This is the instance name, and this instance ID will be invoked internally by the AWS console. Okay, AWS. Right. So we have this particular stuff, and we have instance ID, all this for the private DNS, public IP, everything will be assigned automatically. Okay. All right. So that is so this stuff, right? So we are doing it manually. So how do we do it? So we have spent like maybe 1 minute for this, right? So if we do it, whatever we performed manually, right? So if we do it in the code way, just like a kind of just run the code, then the entire stuff, whatever we have done so far, everything will be done automatically. Okay, that is what we are going to do it now. Okay, right. So first for that, right, we need some environment. Okay, so what I can do is we are going to do it from the Terraform. So let me, I have a Terraform instance already running, up and running in my AWS instance. So what you can do is either if you're having a Mac, directly there itself you can able to install the Terraform and you can do it. If you're having a Windows kind of laptop or environment, there also you can able to install it. Maybe installation is quite straightforward. Okay, install Terraform. Okay, so on Windows or Mac, first we need to do install the, this is a package manager, right? So go with that. Okay. So in our example, I have taken Ubuntu as our base stuff. Okay, provide the list of steps here. Choose the version based on your stuff. Okay, just download it and you can go it. Or else you can directly go with the command. Okay, so this will be. Here the package manager will be the APT. Okay, APT is the package manager. There we are doing homebrew, right? So like that. So you can use either of it. So if it is Mac, you will be using the appropriate what is the package manager. Okay, so let me take this particular stuff. Let me create a new instance. So just now we created an instance, right? Test instance. Let me connect this. Let me connect this particular instance. So all these things you know, right? So the creating the PIM file, everything you know, right? Right? The SSH general you can able to connect, right? How to connect the easy to instance. uh, right?
Yeah, but could you
Okay,
just
so if
walk
not,
through
yeah, if
what?
not, it will give the clear steps actually. So here itself. Once the instance is ready, then you could be able to get the steps here. Just give the connect. See here. Just give connect. Then it will give you the list of options. Either you go for the session manager or easy to instance direct connect or SH connect or open SH something, whatever tool, right? So it will provide you the steps. So go with that.
What is this tool that you are using to connect?
This is mobile XTerm.
Okay,
This is
is
the
it
mobile
open?
XTerm. I'm in Windows. I'm in Windows machine. If you're in, if you're also using Windows box.
Yes.
Okay. Okay. You can do mobile XTerm or maybe Putty. You can use Putty also. Mobile XTerM is easy, like in a graphical way, you can able to manage multiple instances here.
Is
It's
it
quite
free
easy.
open source?
Say it again.
Is it free open source?
Mobile XTerM. And your voice is too low.
No, I'm asking, is it open source? Is it free to
Yeah, it's
download?
open source. Yes, yeah, it's a freeware. Yeah,
Okay, thank you.
it's a freeware. Okay. So to install, right? So to install that, what we'll be doing it. Where is the steps, right? Okay, here. Okay, first apt get. Okay, so first it will try to install all the dependencies. Before that, right? So see, it's a fresh installation, right? The setup of Ubuntu. What we have to do is apt get update first. Okay, update. So it will update all the dependencies, which is the binaries, utilities, everything will be there, right? When we set up the operating system very first time. So when we give apt get update in Ubuntu, then it will take care of. So if it is yum update, right? So it will take care of everything. So all the packages. apt get is a package manager for Ubuntu. If it is Linux, Red Hat Linux, it's a yum update. Remember, right? So you know, right? So yum update. So like yum install, right? Well, like it will give. So here it's apt get install. apt get install. So since in production we are using Ubuntu as a kind of Ubuntu will be used extensively. So I chosen Ubuntu. So if you want like Amazon Linux or Red Hat or SUSE or Fedora, so anything, maybe you let me know. So based on that, we can set it up the environment. Okay, from the next class if you're specific to any kind of operating system. All right. So now Ubuntu is there. So now what I'm going to do is just install the dependencies. So whatever we have done the apt update, it's update the dependencies of OS dependent. Now we are going to install the dependencies which are related to our this thing to install the Terraform, right? Terraform related stuff. I'm just going here and GNU is a kind of security related software. See here, GNU, right? GNU is a GPG is what we call it as. Okay, GPG is Grand GNU package, something I don't remember. Okay, it's kind of complete package. It's for security purpose, some security uh, um, what is that? Security utilities it will provide. So those utilities are required for the Terraform to install to get it installed. Okay, that is the reason we are going for this particular installing this particular software properties, common properties, and GNU. Okay, okay, it is installed. Now I am going to add a key for this so that this particular package will be uh, fully kind of reliable. Okay, it will be reliable. right? Then I'm going to add it to the part of repository. Okay, so HashiCorp repository, this particular the release. Okay, that's all. So once it is done, so this will be taking the particular release. Once it is done, then get update. So whatever we installed so far, the package, right, will be get updated with the OS instances. Then just install the Terraform. Okay, so it will be kind of whatever. Okay, wherever the apt add, apt get, everything is coming, right. So there you have to replace it with yum if you are going for what is that Linux. Okay, if it is home brew, then you have to give the appropriate package manager. Okay, so let me go with this and install the Terraform. Okay, this Terraform install. Let me check the Terraform version. So it will give the latest version of it. Okay, so we are using 1.4.4. Okay, on Linux AMD. Okay, this is available. Right. So this how we'll be installing the Terraform in any instance. Okay. Maybe if you want to have it in the Windows, then simply go here on Windows. Okay, so based on the version, you just choose it. And you give the Windows crash install. Yeah, steps will be quite straightforward. You can blindly follow this particular step, then you can get it. Okay. So Windows, right? Some workarounds are there. To create any instance, right, AWS instance manually, right, what we did is like we create a instance AMI image, then instance ID, instance type, right, instance type we choose, then the key, right. So these are the three key parameters we choose for to spin any AWS instance. Okay, so we tried it manually yesterday. Right? So we tried it manually. So now what we are going to do is we have to do it in an automated way through kind of some through code. Okay, so for that what we are going to use so in automated way we are going to use Terraform. Okay, Terraform. Right. So all these values, right, AMI, image, and instance type, and the key, all these things, parameters, we have to save, we have to pass it as a some key and value parameters, right? So for the Terraform code, so like what we'll be giving is like image equal to image, and the type equal to something, and what is the key equal to. So all these three values has to be passed as a variables, right? The parameters for the code, so that the code will be compiled using these values. Then we will be getting it. The particular instance will be spinning a span on the particular stuff, right, in the console. That is the plan. Okay, so this is what we have yesterday. This is what we have done, and we manually created this particular instance. Then then we installed the Terraform on it, right? So once the Terraform is installed, then we could able to see Terraform -v. So we get the Terraform version. So this is the latest version we are having it. So this particular version is installed. It's up and running. Okay. Now what we can do is maybe I can create a directory, make directory uh, class Terraform. Okay. So let me go inside it. So we are going to create set of files here. Okay, so currently we don't have anything, right? So we don't have anything. So let's try to create. So first let's learn from the kind of basics, like how variables can be able to can initiate it, right? So that is important, right? So we are going to pass these values as a kind of assigning to some variables, and that variable will be used in multiple places, right. So that's how it is. We cannot carry this particular same value throughout entire the code, source code, right. So let's see how to do that. Okay, so what we can do is let me create some file. So Terraform, right? So always will end with tf. Any file name, any file with .tf extension. Okay, it's a Terraform extension. So let me create a file. Okay. So in we are going to create a variables, right? So we have a kind of set of variables in Terraform. Okay. So we have a string, we have a number, and we have a boolean. Okay. These are the three basic types. It's like basic type of variables. Okay. So we have a complex type. Complex type we have. So that is map, map, tuple, and object. Okay. So in production, right? So we extensively use string, number, boolean, list, and map. Okay. Tuple and object will be rarely used. Okay. Then set also there. Okay. So these are the five complex type variables, and these are the three basic of variables we are using in Terraform. Okay. Let's see one by one how we are going to use it. We can so that okay. So let me create test1.tf. Okay, some file maybe variable.tf, test variable.tf. Okay. So I'm in the all these things you know, right? So VA editor and all you can able to use, right? On Linux, right? You are familiar with
Yes.
it. Okay.
Yes.
So take for example, I want to take like a equal to 10. Okay, this is a variable. A is a variable. Okay. So a equal to 10. Okay, it means that a is a key and 10 is a value, right? So key and value. So this how we'll be using it, right? In any programming language or any kind of declarative or kind of functional programming, this is how we'll be doing it. Take for example, I have a equal to maybe a equal to 10. Okay, the same thing. So in Terraform, so we have to define this a is a variable. So variable. So a is a variable, and the value we have to define it as, so 10 is a value, right? So 10 is a value. So for this we have to give the default value as 10. That's it. Okay. So this is the one. So a equal to 10, how it is changed? See, a equal to 10, how it is changed. So we are saying we are just defining that, declaring that a is a variable and 10 is a default value. Okay, so whatever value we are going to assign in a kind of hard coding, so that will be the default value. Okay, even if you are not explicitly sending any value, then by default 10 will be assigned. That is a meaning, direct meaning of it, right? So here in Terraform way, so this is how we'll be declaring it. Okay, so this is how we'll be using any variable. So for example, I have a okay, and I'm just giving it like this. Okay, and what is the type of the variable? It's a number, right? Maybe I can give instead of 10, let me give welcome something. Okay. Okay. So type is a string. I'm simply giving string. Okay. Okay, that's all. Simple. Okay, so a equal to welcome is that's how I'm just defining it. Okay, so the type is string and default value is 10. What is it? Welcome. Okay, let me save it. Okay, so now I need to verify it, right? So we have a kind of console. Okay, Terraform console. How to verify? So console is like a how to say, it's kind of interpreter. Okay, for Terraform to evaluate whatever expression we are trying, right? So all these expression we can able to verify it in the console. It's a kind of interpreter. Okay, so if even if we are running some Java program or Python program or any programming language, we will be kind of compiling it and running it, right? So for the compiler and what is it, interpreter, we need a separate environment, right? So runtime environment. So like the Terraform is having a runtime environment that is called console. Okay, Terraform console is a command. So when you enter it, so it will give some prompt like this. Okay, so we are in the Terraform console environment. Okay, if I simply give variable.ea, you will get the value. See, so it means that that value is assigned to the variable a. That is the meaning here. Okay, so it is successfully assigned. So either I can use it like this variable.a in multiple places to refer this particular, to retrieve that particular value, or what we can do is we can specify this particular notation. Maybe I can say like this. Okay, I can put kind of around this, like this, and dollar. Okay. So this is also possible. Okay. Yeah. So I have to put double quotes around it, surrounding. Okay. This is also possible. Okay. So the best way is like we can either it's up to our convenience whether we are going for like this or this is the this like this. So it's kind of notation how we are going to represent in the throughout the code. Okay. So to refer the code, we'll be using either the dollar sign or directly we can use it like this. Okay. So in production and all, we'll be using like this only. Okay, it's kind of best practice, but there is no much difference. But both are same. Okay. So this is how we'll be using it. Clear, right? So far. Okay, let me go here. Vi. Okay, so maybe I can change it uh, as my key something. Okay, it's a key, right? And maybe I can say welcome is a my value. Okay, my value. It's okay, same thing. I just changed it. It's the same file. Okay, and I'm going to run it console where.a. because A is not available because we changed it, right? So it won't be available in the console. Okay. So how we haven't run this particular variable or test variable.tf file, how this console come get to know that okay there is a variable is declared inside this thing without knowing without actually compiling this particular tf file, how it will come to know? Because it's a console, it's an interpreter, right? So when it comes inside the interpreter and whenever we give like this command, it will actually looking the file inside this other .tf files. Okay, whether this particular variable is declared in any of the files. Even if you have 100 files, then it will be checking it. Okay, so in our case, it's a key variable.key. Then we are getting it.
So does it only it's going to look in the current directory, right?
Yes,
Where
yes, yes. That's so. Wherever we are running the console, there only it will be look up the what is it the
the
particular file.
Terraform files. It should be, and that extension is mandatory. Is it mandatory? Will it only look for files that has .tf extension, or does it look everywhere in the
Yes,
current?
yes, that is mandatory. Yes, otherwise it won't. It don't understand whether it's a Terraform file or it's a different file. Okay, the .tf is mandatory.
Okay.
Okay, all right. Okay, so this is kind of a string type. Okay, so similar like number, right? Maybe I can take it like this. Let me copy this particular stuff. Simple variable. Okay, so I go here. My key number. Okay, so it's a number. Simple, right? So my value number. Maybe, yeah, so it's a string we cannot assign because it's a number. So let me give 1, 2, 3. Okay, I'm just saving it and I'm going to Terraform console variable.myKey. So it will give the actual value my key number. Targeting. Okay, similar way we can give the same notation of dollar symbol, all these things. Okay, so this is a kind of basic level of understanding the boolean also true and false, right? So we can give the true and false value and we can take it. Okay. So let's go to that particular complex type. Okay, that is mostly important. Okay, maybe let me go here, copy this stuff and paste it here. Okay, let me go instead of number and string or boolean, let me go here as a map. Okay, so map is like it will be having kind of dictionary values. Okay, similar like key and value, similar like key and value. So it will be having a this is the map and this is the key and this will be having a value as a key and value. Okay, let me explain that. Map as string. Okay, so it is having a string value. Okay, so default instead of 1, 2, 3, so I will be giving default equal to. Okay, so I'm going to give as like this. So default also will be having set of key and value. The value itself is a key and value. Is what I'm doing. Okay, it's like my map key something I'm doing. Okay, and my map value. See, this is the default, if you are directly assigning it here, it means that, so whatever the my key number, right, my map key. Okay, so whatever the variable I'm defining as a my map key, as a map type, okay, it will be having some value. Instead of directly assigning the value, so the value is itself is like a key and value. Okay, so we can so why we have these things, like for the security, right? So we have SS key to tokens for authentication, and for all the credentials, right? So we'll be using map. Okay, so it's kind of so internally it will use some hashing algorithm in the interpreter runtime, so it will be using that. Okay, so we'll be having a multiple data like this, and we'll be retrieving it. Okay, so here it is a one, right? It's a one-to-one mapping. Okay, so it's a variable, it will be having only one value, but here map, right, we can able to have key and value. Okay, so same key can have multiple values, something like that we can able to assign it. Okay, so here we have a map, and let me save it, kind of dictionary. Okay, so let me go Terraform console, and let me give variable is equal to variable is what I have given. That, okay. So where dot what is that map key, right? So see, we are getting the actual map where it is retrieving. If you are having a multiple key and value, we'll be having everything. So if I want to go for the specific, okay, so in that case, what we'll be doing is we'll be go with the specific of the particular key of the particular key is my map key. Okay, so if I want to retrieve it, the actual value. So like that, we can have n number of keys. Okay, so we can have a number of keys. So but here in the variable, right, so direct variables, we cannot have the multiple default values, obviously, right? A variable can have only one value, but here a map can have a number of values in a dictionary order, in a key and value order. Okay, the same thing we can have it as a like this. Okay. Uh, that is simple, right? Like this we can able to refer it.
Yeah, can we consider it as an array of elements?
Array of, yeah, so
Element
for
of.
that we have a list. We have a list.
Oh, okay, that's different. Okay,
Okay, so
fine.
that we have a separate list. Let's see that also. uh, okay, so let me go with that. So maybe I can choose this, my list key. Okay, maybe I can say it as my list. And okay, so here I can type it as, instead of string, right, I can take it as list, and default I can give array. Okay, so array. Maybe I can say 1, 2, 3, 4, 5. Okay, something like this. Okay, it is closed. Let me save it. Okay, it's a list. Type is list and list key, or maybe list key. Okay, okay, Terraform. Okay, so okay, where dot my list key. Okay. It will provide everything, right? So if I want to go with a specific kind of iterative or kind of index based, right? So what we can do is, let's go with 0, and we'll be getting the first value, right? So we'll be getting the respective values, right? So if I choose like kind of the element, right? So instead of like this, I can do, maybe what I can do is element of particular stuff. They can give us to Two arguments. With the same two arguments. Okay. Okay. So it will take the particular element and it will give to us. Okay. So the index will start 0, 1, 2, 3, 4. Okay. So this is also possible. Or if we can go kind of slice, kind of range. See, for example, instead of element, if I go for slice and 0 to 2, okay, so we'll get that value. Okay. 0 is 1, 2, 1, 2. Okay, so that kind of values we can able to retrieve it. So why we have the kind of list and all. So assume that we'll be having multiple AMA images. Okay, so I want to choose the AMA images based on the region. Region will be stored in somewhere, maybe in the map. Okay, so AMA images will be stored here, right? So based on that, maybe if I want to choose a region from that particular variable and AMA image from the particular variable, so in that case we'll be using the list. So in production and all, we'll be extensively using the list type. Okay, so having knowledge on string, numbers, boolean, map and list is kind of more than enough for the production to work on. Okay, so yeah, clear, right? So whatever we discussed.
Yeah,
Right. So now what we can do is let's with this knowledge, right? Whatever we this thing. So let's create a instance through Terraform core and let's spin that. To spin that particular instance, right? So what we need is we need a AMA image instance type. Obviously, we know like T2 micro or all these things, and the key. Okay, so what we have to do is we have to create a first we have to know the image ID and all. So if we go here, what is the Ubuntu images here? So if you go this particular cloud images Ubuntu locator at EC2, okay, so it will give the list of images, image IDs, AMI so 5612 AMI kind of, if you want 18.02 04, so we'll be using this particular AMI ID. Okay, so any whatever the flavor you have, right? So based on that you can choose it here. See, you what is it? Asia Pacific South one, and it will be choose. Okay, here the okay. So based on that we can able to filter it. If it is like Canadian, we don't have this kind of yeah, any or US East one, and we have okay. We don't have the OS type, so all these things we get to know. Zenial or maybe let me check. Yeah. So if we go here, you'll get to know all the images, all these things. Okay. So you just blindly can Google it and you'll get the actual page instead of go with the searching and that. Okay. See. Okay. So ours is like Zenial Express. Okay. So for Ubuntu, right? So this is what we have chosen. See, from here also you can able to get it. Just go here or maybe launch the instance. Just for the sake of understanding where we can able to get the instance ID. Okay, launch the instance. Okay, choose Ubuntu or any flavor, whatever you are. See here itself, we can able to see AMI 00785, right? So you can able to see it. So the same image will be there. Okay, either you can take it from here or you can collectively you can in the same page. Okay, the purpose of Terraform.Tfstate file is once we created the infrastructure, that current infrastructure, what is the current state of the infrastructure, which will be stored in the Terraform.Tfstate. Okay, so either we can give like Terraform cat a particular file, we can get it in this way. Okay, or else what we can do is we can give Terraform. So this also will give the same, both are same. Either we can directly print out it or we can give it a Terraform show. So both will give the exact, okay, currently there is no resources represented. We have removed it everything. Alright, so maybe, okay, maybe Terraform apply, try, so that we can get some value here. We can see. So it is going to add two instances, two resources. So one is the instance, other one is also instance. So two instances will be done.
Let me ask you, Jay, can we overwrite if we have an issue with a state file?
It won't. Okay. It won't
So can we
overwrite. So it.
yeah,
Say it
can
again.
we, is it a typical practice to take the backup and overwrite the first state file? So for instance,
Correct. Yeah. So there is a state file version 1. Then when we apply some more changes on top of it, then it will be overriding the same state file. So it won't create multiple state files. A single state file will be overwritten on top of it. So here there are two instances are running now. Now if I go here, cat of the particular Terraform state, and it will give a list of what is actually thing. Or we can give Terraform show command. So this also will be uh, give the insights about the particular stuff. Okay, so whatever the infrastructure is currently created, all those details you can get it. Yeah, so this will be having a only reference. Okay, this will be having only reference of the
do you
actual file.
do you
Okay, it
ever
won't
copy
have.
from that backup? Do you ever
It
copy from that
won't.
backup?
It won't. So this backup, right? So if the TF state file is kind of it's corrupted, from here we can able to retrieve it for that purpose. So it will be having all the references. Okay. So
Okay, so when
even
you
though
can,
this is the one of the way,
this
the
is not
other
the
way is
latest.
it's not. It is
Okay.
related. It is related to both same thing only.
Oh, they're
So this will
identical.
be having.
Are they always identical every time? Are they always the same? Backup and the backup and the original, the dot backup and the one without the dot backup, are they always the same? It looks like
Right.
the dot backup contains the previous state file before you ran Terraform apply.
Correct.
My question is, have you ever had to use the dot backup, do like a copy, a CP command to copy over to the .tf state file? Have you ever used the dot backup that way to recover
Okay.
from a bad TF state? Have you ever used the dot backup? Yeah, so you see it has nothing. So maybe somebody ran Terraform plan and they were not supposed to run Terraform apply, and they created some resources. Have you ever used the dot backup to copy over the the current state TF state file to overwrite
Uh-huh.
it? Have you ever done that?
Okay. So backup is just for a reference it will create. So it does not have any current state and all. Okay. So in case if the original file is got corrupted, okay, so it will be having kind of some ID and all, right? So what is that? Yeah, no, it is not providing anything. So it's a temporary file. So it will create a backup file when actual infrastructure is built. After that, it will be creating the original file. Okay, so to prepare the original file, the backup file will be created. Okay, so it does not have any more insights. So if any case the Terraform Tfstate file is got corrupted or got deleted, how to retrieve it? So we cannot retrieve it through backup. We can retrieve it through terraform.refresh command. Okay, so through that command only we can able to retrieve the Tfstate. So it doesn't mean
So
that
so
backup is a, yeah.
so you don't use it. So why you take it? So why is the backup generated if you cannot use
Yeah,
it?
so that's what. So when we run the Terraform plan, Terraform apply, okay, so that time only it is actually applying the changes into infrastructure. So that time it will prepare the infrastructure and get the existing TF state. It has to override, right? It has to override the existing TF state. That time it will put
Yes.
everything in the backup. Then it will be
Yes.
override there. Then it will be remove it from the backup file. So it's a kind of temporary place where before the TF state file is prepared or overwritten.
So there's
TF state
nothing.
will
Oh,
be,
so,
it is
oh,
not the,
okay. So there's nothing in the backup file. It doesn't have anything.
it is not an actual backup. It is not an actual backup. It's a temporary backup at runtime.
At runtime. Gotcha.
Yeah.
Thank you.
Okay. Just to prepare the TF state file,
Thank you.
because that when the TF state file is already having some data, so the data has to be written and overwritten. So that time it cannot apply two permissions on the same file. So for that it will create some this file and write some data. Then it will overwrite this particular data and remove everything from this backup file. Okay. So if you see here, see there is a ID, right? Lineage. Okay. So this particular ID will be maintained everywhere. See here, the TF Terraform state file will be having the same lineage. Okay.
Mm,
So based on that, it will just give the reference. Okay, this is the file. It is going to take a copy of it at runtime.
so if
Okay.
there's any
So nothing
corruption,
else.
if there's any corruption at runtime,
If it is any corruption in the TF state, then we will be doing terraform.refresh, Terraform refresh command. So that will be cure the TF state file. Okay, so from the current infrastructure state file, then it will create TF state file. That we'll be doing it now. Okay, so
gotcha.
yeah, so now we have these two files, Terraform state file. So this will be having current state. We can give Terraform show. Okay, so this also will be giving the show of TF state. Okay, so it will give in the JSON format in a proper readable format, and so all the insights about the current infrastructure. Okay, so let's assume I am going to change it manually. Okay, so for example, I'm just changing this particular. Maybe I can let me. Okay, I just want to change. Let me stop the instance. Okay, instance statement stop. Okay, maybe what I can do is vi ec2. Okay, so here let me go. I just removing one of the machine here, destroying the second machine. Okay, so just to explain the other scenarios. Okay, so now what I'm going to do is we are having one infrastructure, one instance resource we created. Okay, so that resource I'm going to manually change it. Okay, manually changing something in direct UI. So here, so far what we learned is directly from code only we are designing the infrastructure, right? We are preparing the infrastructure based on the code. So now what if I change manually in this particular infrastructure, like changing some what is this particular instance type, or some security group, adding some security group or storage classes, something I'm doing it manually. Okay, how the TF state file will be maintaining its state? Yes, the TF state file will be maintaining the current state, whatever is currently implemented in the AWS console, right? AWS infra, the cloud, right? So, but if I change it manually, the Terraform TF state does not know, right? So,
Yes.
if we do some manual changes, so how it will be get automatically updated. Okay, so that only we are going to uh, do it. Okay, so for that, right? So what I can do is let me stop the instance. Let me stop the instance. Maybe if I want to change some kind of for the instance type. For example, instance settings. So instance changing instance type is not allowed when the instance is up and running. So let me stop the instance, and okay, so it is stopping. Okay, instance stopping. So there is some change happened on this particular instance, which has been created by our Terraform code, which tfstate file is maintaining. So if I go here, Terraform, okay, plan. Okay, so I'm giving Terraform plan. Let's see, it will say that it is up to date already. Okay, it won't show any changes. See, there is no changes, but there are changes. I just stopped it, right? It is stopped. It is not in
Wait
running
a
state
minute.
because we are not maintaining. Why it is saying no change? Because we are not maintaining its state, right? It is status we are not maintaining.
You just
We are
destroyed it
maintaining.
though. You
Say
destroyed
it
it just
again.
now. You just
Yeah,
destroyed it.
we destroyed one of the instance, not both instances. See, we destroyed the second one.
Mm.
Okay, we destroyed second one, not the first one. Okay,
So you're saying that
so
because it stopped? Okay.
yeah, so okay, so here in the code, right? If you see cat ec2, we are monitoring only the instance type. Okay, so if I change instance type, then only the Terraform plan will report us there is a change. See here, if I give Terraform plan,
Mm-hmm.
then it will say no changes. See, now it will be saying no change. Okay, because Terraform plan lookup. Okay, this is the only attribute that we are monitoring against this particular instance. Okay, so this instance is lookup only instance type or maybe AMI. So if I make changes any of these two, then only the Terraform plan will report. Okay, there are some changes because those two changes only we are monitoring it. We are not monitoring state of its. Okay, state we are not monitoring. See like this, VI EC2. If you are monitoring like this, the state equal to running, then it means that okay, so it is maintaining the state as running. Now it is stopped. Now it is stopped. So there is some change. Then the Terraform plan will definitely report us. Okay, there is a change. Okay, since we are not maintaining the state here and we are monitoring only these two changes. So if you are
Mm.
making any changes on these two, then only the Terraform plan or apply will be give effect. Okay, let me go here and change something on the specific
Wait.
attributes.
Did you, when you put running, did it complain?
Say it again.
When you put running, did it complain?
We
When you
put
put running, what did the Terraform plan say the state has changed?
there is no change.
It still says no change. Can you put running and let's see if it complains?
Okay, want me to run plan again?
Yeah. You put running, right, in
Yeah, it will
ec2.tf.
still show. It will still show no changes. We
What
haven't
about
changed anything, right?
ec2.tf? Can you put run? I thought you put running in there. Running to see that the
Oh,
state
okay,
is.
okay. Running, I haven't changed it. Okay, running, I
Oh,
haven't changed it.
I thought you added it.
Yeah,
You
I haven't saved it. Okay, just to show you, these are the two attributes we are maintaining from the beginning. So
mm-hmm.
only the changes, if you are making on these two only, the Terraform plan will be report us. Okay, so in case if we have a state as running, then we'll be having that particular stuff. Okay, maybe yeah. So let me try that state as running. Okay, so let me save it. I just saved it. Okay, saved it. If I give a plan, then it will report us there is a change. Okay, so the status, not state, it is status. Okay, maybe I'll Yeah, so it is instant state. Okay, so it is running, pending, all these things we can give. So it's an instant state. So let me go there and change this instant state. Instant state. Okay, running. Instance underscore state. All right. So if I give plan, then definitely it will show us there is a difference. But it should be a running. Let me leave it blank. Let's see what is. This will be decided automatically based on. Okay. So let me assign it. Instant state will be no need to assign it. It will be a need some value. We need to set some argument. It is some argument.
Do you
Just a
think
second.
it is only supported at the time of creating an EC2 instance?
Which one?
Do you think it is only supported at the time of creating an EC2 instance?
Yeah, it will support the time of creating. So that's creating the EC2 instance only. So so we are creating here only, right? This instance only.
Okay.
Okay. So here if you see AWS instance, and so it has lot of attributes like AMI attributes. So we have AMI instance. Oh, okay. Okay, maybe I'll get back. So why it is not instance state is not taken? Okay, I'll get back. Okay, for now let me comment it. Comment this particular stuff. Okay. So the change is right. So if here the catch is the point here is since we are maintaining only these two attributes, right? And if you are manually modifying something on this particular directly console, okay, on these two attributes, then only the Terraform plan will report. Okay, otherwise it won't report. Okay, otherwise it won't report saying as no changes. Okay, so let's wait. Okay, it is saying no changes because we are made these are the two attributes we are monitoring and there is no change on these two what is the attributes, so it is saying no change. So if I make some change here, instance settings, okay, I'll come back to that particular instance state why it is not allowing. Okay, from t2 small is the one which is already available in tfstate file, right? The current state file, the plan file. So now I go here in T2 small to maybe T2 micro. Okay, maybe T2 micro. Okay, T2 micro. I'm going to change it. So actual implementation is T2 small. Okay, I'm going to manually change it as T2 micro. Okay, let me apply it. So we have manually modified it. Okay, we just modified it manually and let me read. Okay, Terraform plan. Okay, see, it is saying there is one change. Why before it was not showing? Because these are the only two we are doing it, right? So either AMI ID, AMI image, or instance type, right? So those are the only two attributes we are monitoring or we are creating the instance. We are having a control on these two, right? So not instance state or nothing, right? Or anything else. So only these two. So if I make manually any change on these two, then Terraform plan will report us, even though there is no change. See, there is a change from T2 micro to T2 small. Okay, so now if I so you don't use something, so there is a change, it is catch, right? So similar like so if I give at terraform tfstate. Okay, now you see it will still show tf small only. See, so T2 micro is not at changed because tfstate file is still showing the older value. Okay, the older value. See, now it is actually T2 micro. Okay, so the TF state file does not have the updated value. So if we want to get the updated value, what is there in this particular the infrastructure, actual infrastructure? So what we have to do is we have to terraform refresh. Okay, if we do refresh, this TF state file will be get refreshed based on what is the current state. Okay, then the desired state also will be modified. Now you see. So terraform refresh. Okay, so it is refreshing state is this particular stuff. Now if I go here and cat pf state file, earlier the before it was showing T2 small. Now if I go, okay, it should show T2 micro. See, it is in the stopped state. Okay, it is giving the current state of whatever is there. Got it, right? So that's how we can, if you are modifying something on this particular directly on this thing, then this will automatically take it. Okay, so if I give Terraform apply and make some changes, this also will be down the instance and apply the change and bring the instance up. That's how it is. So now it is stopped state and whatever state currently it is showing, the same state it is showing it here. Clear, right? Or any doubt here? Okay, so the state file will show both. Okay, so here terraform show. Okay, so it will actually give it in the JSON format of tf state file. So it is saying tf state file see instance state and instance type. Okay, under this particular resource. Okay, same thing. If I cat terraform Terraform.tfstate file, that also will be giving the same as it is. So it won't group the stuff, but it will be giving the raw JSON format. But this will be kind of grouping the blocks and everything. Okay, like DNS and all will be grouped, and kind of what is it? The capacity related, and what else? The attributes all will be grouped based on the particular block. Okay, based on the resource. Okay, but here it is not like that, so it will be kind of raw JSON. Okay, so basically the tf state file will be always matching the desired state and the current state. So current state is the one what is there here in this particular existing. Desired state is the one what we are going to apply. Okay, so basically we will be maintaining some naming convention for the files. Okay, so we don't simply create any Terraform files. Has some standards. Okay, so it has some standards. So we call it as configuration directory. Configuration directory. Okay, so this will be having, so main.tf will be the one. The Terraform will be take it will be kickstarted. Okay, so Terraform and provider.tf. Okay, and output.tf and variables.tf. Okay, so these variables.tf we have a Terraform.tf Okay, so there are some approaches how the variables will be looked up. Okay, so it is like say for example we are declaring a variable like a equal to 10. Okay, maybe instance type equal to t3 dot large. Okay, so like this I'm kind of creating an instance. Okay, when we do like this particular instance type, if I don't, I'll be referring it somewhere, and I don't pass any value. Okay, so how this particular value will be fetched, even though if I use it somewhere. Okay, so those things it has some approach. Okay, okay, so here that is equal. Let me come back here. Okay, see here instance type equal to t2 small. We are supplying some value here, hard coding some value here. In case if you are not, if you are not giving some value, any value here, then how this particular instance type will be resolved. So so basically why we go for variables, like maybe I can show we have a fifth var, right? Fifth variables. We are defining a variable like this, my key type equal to string and where default value something like this, right? So why we are going for variable? So if I want to define some value, or maybe some repeated, this may be this key, maybe this variable may be kind of I will be using it some in many places. So those places I don't want to keep on repeating this particular value and this key, right? That time I can able to have it as a variable and the value, and wherever I want to use this particular value, I can simply refer this particular variable name and I can get it. In future, if you want to change the value, I can simply change the value here. So and wherever it is referred, so everywhere this particular value will be applied, right? So hard coded value also I can able to supply it here, or maybe repeated stuff also I can able to resolve it using the variables, right? So let me try to create a kind of some security group. Maybe instead of trying with always instance, right? Let me try with security group and we'll try it. Okay, maybe Terraform. One instance is going to destroy 64E8. 64E8. This is the ID it is maintaining. Same ID it is here. Okay. Okay. One instance is destroyed. Okay. So now what I am going to do is maybe I can create one. So like what I'm okay, security group TF. Okay, so let me create it so that how the variables can be okay. Resource. Okay, so resource may be how do we get the resources? Go here. If we want to create security groups, so that will be part of uh, VPC, right? So let me go to VPC. There is a VPC, VPC private cloud, and AWS security group. Okay, go here. You'll get to know how to create it. Right, so here's the security group, resource security group allowed TLS, something like this. Maybe we can use it same as it is, or we can just copy paste whatever you want. Okay, so just go here. If you want to get security group like this, maybe I can give demo where's variable later only we are going to approach it here, not kind of something like this. Okay, maybe I can use it same stuff. Okay, name demo variables, and we can say like okay okay, so here I no need to mention any VPC. So here if you see that they mentioned VPC ID. Okay, so it's up to us whether we need to create, because security group won't live on its own, right? So it has to live part of a VPC, right? So security group will be assigned what is associated with the VPC only, right? So we have to kind of associate some VPC. So if you are not giving any VPC here, simply we leave it as it is, then it will take the default VPC. Always the VPC will be available, right? In any, you go here, where can I see the VPCs? VPC, yeah, go here, and you may be seeing that set of VPCs. Okay, so if you want to create a security group on a particular VPC, then what we can do is there is only one VPC. Okay, there is only one VPC. So if I have multiple VPCs, for example, like this VPC only, manual, something like this, and create VPC. Okay, okay. IPv4 172 dot 23 dot 43 dot. Uh, Simply I'm giving something. Okay, spider, this is 32. Okay, so I'm just creating a between 16 and 28. Okay, it's a VPC, right? Ah, why the cider notation is reporting like this? Why the cider notation? Any idea why it is showing some error? Okay, maybe that's the correct one. It's very right. What is wrong with this? Okay, 172. Let me choose this one. The network port I have given some. Okay, so here VPC we have created, right? So if I go here, and we have two VPCs, right? So if I want to create a VPC under this particular VPC, so I can copy this, go here, and I can give VPC underscore ID, and I can mention it like this. Okay, so this particular security group demo was will be created under this particular VPC. If I don't specify anything, then automatically it will take the default VPC. This is the default VPC. Okay, so let me remove this because this will be a cost. Okay, so that is simple. So you can mention either, I can mention the VPC ID, then the particular security group will be created under the VPC ID. If you are not mentioning, then default VPC will be picked up. Okay, so it will be, so in our case it will be automatically picked up the default VPC. Now let me create some ingress. Okay, ingress, because security group will be played on the ingress, right? So let me give ingress. I can give from port. So everything we can see it from here itself. So it will give the default details from port to port, everything. Okay. So maybe I can give 443 and to port as 443. Okay. And what else? Protocol. TCP. So we are creating ingress rules here. Okay, for security. Okay, so protocol given, and what else? How
Okay,
we can give
what is
writer
the
block.
meaning of
Tell me.
ingress?
Say it again.
What is the meaning of ingress?
Okay, so ingress. Let me go here. Okay, so if you take any service or any service, some service is running. Okay, if service wants to accept some inputs, okay, that is called ingress. Okay, so through which port it is accepting the input, that is ingress. So through which port it is emitting its output, that is egress. Okay, we have ingress and egress. Okay, so here the service is like, the resource is like security group. Okay, so here in the microservices we can have a, we can think about it, it's like a service, right? Security group is a service, it is providing some security related aspect. So it is accepting all the inputs through this particular port. Okay, that is ingress. So ingress is the one which will accept, so egress is the one which will emit, which will be a kind of output. Okay, so that is egress. Clear, right?
Yeah, thank you.
Okay,
Sorry,
so
you said something about Kubernetes. Are you saying that the
say it
ingress is the
again.
same as you said something about Kubernetes? Are you saying that ingress is the same as a service that accepts traffic, incoming traffic?
Correct, yeah. So incoming traffic, right? So where it has to, through which port it has to receive it. So that is ingress. Okay, so it has to accept some. So there is left hand side and right hand side. So left hand side is ingress, so it will accept it. Right hand side it is giving back. Okay, so giving to some, to the world. So that is egress. Egress is always emitting or output. So ingress
Yeah.
is input.
So I'm just curious
Right.
what you meant, how you related it to Kubernetes service.
In
I
Kubernetes
know that's
service.
you said something about a service. Okay, don't worry
Yeah,
about
so
it.
in
Sorry.
Kubernetes we have a service, right? So in service we have a kind of input service. What is that? Node port and all we have, right? Node port, load
Mhm.
balancer, and cluster IP. So everything will be having some port. So through that port only it will be accept some input, right? In
Gotcha.
microservice architecture. So if you take any service, that service will be accept some input through some port, as well as it will send some output through some port. So everything through port. So whatever port it is accepting, right? So that will be the ingress. So in
Thank you.
Kubernetes we are having ingress, right? So ingress is like a, it's kind of service, right? So in Kubernetes, so this will be
Thank
having
you.
a, that will be having a ingress service, that will be from outside, how it is kind of accepting all the traffic. That is ingress. So we will be having ingress controller and all in Kubernetes. Yeah.
Yeah, one
Gotcha.
question.
Yes.
Usually, right? For example, if we take SSH service, it
Hmm.
works on port number 22. Is it not the same port for both ingress and egress?
Yeah, that also we can give. So I'll tell you now. I'll
So
tell you. So in
my confusion is, why would there be different ports for ingress and egress? Usually, if there is a service, both would be similar, right? Can you give an
okay,
example where
think
it
about
would be
this way.
different?
So you have a room. Okay, you have multiple windows. Okay, if you open the window and you will be seeing through that window, you will be seeing a forest. Another window you will be seeing a kind of some ocean. In another window you will be seeing a desert. Okay, so through a forest window you will be getting some nice kind of wind. Okay, so that window will be a port of 443. Think about that. Okay, so each and every window will be, you will be receiving different type of data. Simple. Okay, so if I want to access that particular room, I have three options, and through those three options are three windows. One window is forest, another window is ocean, another window is desert. Okay, if I approach the kind of through a window which is having a ocean, okay, so it will that particular, through that window I can apply only the ocean related data only I can able to pass it. Okay, if I want to approach, if I want to kind of send some data inside the room through a desert window, then only the desert related stuff only I can able to communicate through that particular window. So here I mean the window is a port. Okay, so I have a three port and the room is a service. So I have a service, and that service having a three window, it means a three port, and one port will accept only the kind of some related like security related stuff. Another will be kind of SSH related stuff. Another window maybe like maybe like there is no security, so it's kind of free to open any other public stuffs. Okay, so this kind of ports we are just segregating how to kind of reach that particular service, how to utilize, how to use that particular service. Okay, so the maybe in the next ingress, right, I'll be copy paste it and I'll do it. Okay, so that you'll get to know. So why we are having multiple port means each port will be having some restriction or some flavor or some method of handling the data. For that only we are having a different ports. Okay, some port will be port 80, will be accepting all the http request. So this 443 will be accepting https request. It's a secured way. Okay, so if I give ssh, that will be kind of ssh where we can able to kind of connect the particular machine. Secure shell, right? So okay, security group.pm. Okay, so you right, so is this, you get it right. So we'll be having a different port for a service. That is, the service is going to act in a different way based on what port it is received the, through what port it is received the input. Based on that, the service will be behaving in a in that particular way. Okay, so resource maybe I can copy paste it instead of typing it. Okay, so AWS security, maybe instead of allow TLS, what we named is demo, right? So let's try with the same demo var, and this also demo var, and this one we don't want. So VPC ID also we don't want. All those things are optional. Description also optional. We don't want TCP. Okay, cider block is there. So let me hard code. We don't want IPv6. Let me remove that for now. Okay. So cider blocks. Okay. So let me remove this. We hard code the value here so that I can explain you how the variables are handled. Okay, so let me give here 10.20.30.40 slash 32 as a side block. Okay, so now this particular security group having one rule. See, maybe I go here, go to security groups. Okay, if I go here, I'll be having two security groups. So default one and the one which is created. Let me go here, or maybe security groups. Okay, it has lot of inbound rules, outbound rules. That is ingress and egress. Okay, ingress and egress. So there are some rules. Rules means how we are going to act, use this particular service. Okay, how this service will be going to behave through inbound. Okay, if you are sending some data, how this particular service will behave, and how the service will be kind of sending some data through this particular outbound rules. Okay, if I go here inbound rules, see here there are a lot of rules. I have a HTTP, that is will be accessed here, all traffic, HTTPS, all TCP, all these are rules. All these are rules. So this is the same rule, we are going to create it through code. Okay, so this is the one of the rule. Okay, so manually whatever we are doing it here, the same thing we are doing, we are going. So let me go here, inbound rules. Okay, so go here, add rule. Where is it? Add rule. Okay, so go here. Maybe if I want to give SMTP and give some anywhere from IP address and give this particular stuff. That's all. So this is one of the rule. So through SMTP, I can able to access this particular security group can able to access through SMTP protocol. Okay, that is the, so that's how we are just defining the service, how we are going to consume the service through consume the service, and how the service will be behave based on the rules what we are defining it here. Okay, so all right, so now okay, so now I have ingress rule. One of the rule is 443. Maybe another rule I can give it is, as you said, right? So it's maybe what is it, I can give it as 22 something, maybe 22, 22. Okay, so let me give this as this also will be safe. Okay, let me go here. Let me paste it again. Maybe this also
So,
will be like
so Jay,
paste
as
it.
you said, port number 443, right? Uh,
Yeah.
let's take that this is a HTTPS service runs or makes use of this port. So, are we also going to add an egress rule for the same port because the
Okay,
HTTPS
so
service?
we are not focusing on the egress now. Okay, so that will be covering it when we extensively cover security group alone. Okay, now our ultimate aim is variables, understanding the variables.
Okay,
Okay, so not about understanding the egress, ingress, and all. Okay, not now. Okay, just to understand how I am going to manipulate or kind of managing the variables. See here, I'm having this particular value is repeated, right? 10, 20, 30, 10.20.30.40/32. This particular value is keep on repeating. So how I am going to handle this particular repeated value and hard coded value in the kind of variables. Okay, that's why I named it as demo variables, not kind of security. We are not going to give security. We are going to create a security group, but not seeing security group extensively now. Okay, so we'll be doing that later, but now the scope is like only the variable, understanding the variables. Okay, so now you see cider block is hard coded, right? So cider block is hard coded. Now let me, so we have a three, what is that, three ingress. Okay, three ingress. So understanding about security group will be covering later. Okay, so not now. Now the understanding is like variables. Okay, so All right. Okay. So we have a file. Okay. So now we have this particular stuff, right? So this particular file is there. Now what I can do is like this particular variable, right? So this particular value is keep repeating, right? It is hard coded value and it is repeating. Now this particular value needs to be handled. Now if you see Terraform plan. Encoder while generating this plan. Invalid provider configuration. Why provider registration AWS 61 it was. Now it is 62. Yesterday when we see it 61. Okay. The configuration is no valid such as this thing. Okay. Yeah, this is because of we don't have any access. Okay. Maybe what I can do is cp security group here. Terraform plan. Then we'll okay, so it is two things going to be added. Okay, so let's see, it's a cider block, right? The cider block and this one instance and another one is the actual instance will be going to create it. Okay, the instance is not available now. The instance will be created and the security block also will be created. Now what we can do is let me create a variable. Okay, let me create a variable. Maybe variable is here. Maybe what I can do is cp provider to one slash. So let me create a variable dot tf. Okay, so let me create a variable.tf. So this will be like variable. What I can say, it's a client IP. Client IP. Okay, so this will be having a default value as okay 10 dot okay 10 dot 60 dot 60 dot 60 slash 32. Okay, simply I'm going to give like this. This is a variable I'm going to save it. That is the variable I'm going to save it. Okay, maybe before that. Rm minus r of variable. Okay, so now if I give Terraform plan, okay, so it will create one, right? So one security group will be added. Come on, yeah, one security group will be added. So let me give Terraform apply. So create a security group on the default stuff. Let me give yes. Okay. The security group demo was is created and one is added. Now if I go here and just refresh it, we'll be seeing that there is a demo var. See demo var. It is created. Now let me click this. If you see inbound rules, These are the things we created. This is in 443. This is in port 80. This is port 22. See, that's how. See, port 80, port 443, port 122. Just 22. And the source is 10, 20, 30, 40. Same thing, whatever the inbound rules we created, right? So if you want to create it manually, what we will do? Edit the inbound rules, and what we'll do? Add the rules. That's how we'll be doing it, right? So instead, we are doing it through code, right? So that is what we have done. That is what we have done. Now, what I'm going to do is, here the catch is, I want to create a cat security group. Here everything is hard coded. Now I don't want to hard code it, and I don't want to repeat the value. If I want to change the value as kind of instead of 10.20, maybe 60.60.60 something, I don't want to change everywhere here. Okay, I want to keep it somewhere, and there if I change it, everything has to be automatically applied. Okay, so variable dot tf, let me go here. Okay, variable and client ip, client underscore ip. Okay, so default is 10.60.60.60/32. Okay, so this is the one we are doing it. Okay, so variable. Now this particular variable, I am going to reuse it. Okay, so this particular variable client IP, I want to reuse it on these particular places. Wherever I want to use this particular variable, and I can reuse it. Now you see security group. I go here. Okay, so let me change it wherever I am. Go side block. Okay, so here in the side block, what I'll do is I'll remove the hard coded one. Okay, here I'll be referring the variable. So variable is I have to refer where dot. You remember? So in the for day one class we mentioned the Terraform console. There we'll be mentioning where, or we'll be giving the dollar symbol like this and all. Right? Anything is fine. So the simplest way is where dot. Okay, where dot client underscore IP. This is what we have given in the variable. Okay, so this is how we will be using it in a Terraform code going forward. Okay, so where dot client underscore IP. Okay, okay, this one maybe I can leave as it is. Okay, so that we can see the difference. Okay, only for port 80 it will show 10, 20, 30, 40. So rest of the ports 443 and 22, the client IP whatever we defined here, client IP, the value 10, 60, 60, 60, 32, that will be supplied. Okay, so if we give Terraform plan, now you see the difference what is going to happen. The changes, right? It will show the change. See, the change will be on the, see here it is saying minus, right? It will remove this two and this, all these two, right? Port 80, then it will be add all these two. Okay, so let's do apply. For W apply. Now you see. Okay, now you see. Let me go here. Demo wars, inbound rules. See here, it is changed. 10, 60, 60. Okay, so that's how we'll be kind of handling the variables. Okay, in multiple places. If I want to change it, I don't want to touch this particular security group and all. Okay, I don't want to change it. So only the variable file. Okay, so this is how going forward we'll be segregating the data. Okay, so variables will be in a separate thing, provider will be in the separate file, and kind of what inbuilt variables will be the separate file, resources will be in the separate file, kind of storage related resources will be separate file. Like this only, like this we will be going to have it. Okay, so for this only the we have I just showed this particular security group. Okay, so even though it is simple, but the in-depth knowledge about security group, ingress, egress, and all other parameters like what is that tags, no, that's all right. Ingress, egress is the one main thing. Security group. So all these things we will be seeing it when we really kind of creating the security group with multiple options. Okay, the actual resource. So we just showcased what is it, the variables, how to handle it.
All the files should have .tf extension, right? Somewhere I saw,
Extension,
yeah, it's about the extension. We
right?
created all. I don't know. Somewhere I saw. I think it's the variable file. It has tf var extension. Is that valid one?
Exactly. There is a difference. So we have two separate items. Okay. So one is TF, the custom variables, as well as Terraform variables. Okay. So we can have custom file, custom.tf files, or Terraform.tf vars. Okay. So it means that okay, so there are multiple approaches where the variable assignments can be looked up. Okay, say for example, the instance type I have given T3 large. Okay, so I'm just declaring it. Okay, but that value where it will be fetched. Okay, it will be fetched from the environment variable first. If it is not available, then from the command, whatever command we are running, right? Terraform apply or Terraform plan. So there it will be look up. Okay, if there also not available, some file, okay, or some default value means some variable, whatever variable we are defining, right? That way file means the whatever you said, custom file, custom.tf or terraform.tf was, that we'll be seeing it, okay, the next class. Okay, if it is CLI, whenever we run terraform plan or terraform apply, that time itself we'll be applying something like this, variable value is like instance type equal to, here itself I can able to t5 medium, like this I can, while kind of running the command itself I can able to supply the what is that the attribute values, key and values. I no need to mention it like this. Okay, or in environment variables. Okay, or in environment variables we can define it, from there we can retrieve it, and we can deal with the variables. Okay, so these are the multiple ways. First it will look, this is the order, actually this is the same order. Terraform will look up any variable and its value. If nothing is available, we are not mentioning it anywhere. The variable is not mentioned in environment variable, or in CLI we are not mentioning in CLI, or we are not giving passing any value to the variable in any file, or we are not assigning the default value for the variable, then it will be prompt us. Simply if we are giving a Terraform apply, then it will prompt, okay, enter the value now, something like that, it will prompt. So Terraform keeps the remote state file of the infrastructure, right? So having the whole infrastructure, so how the infrastructure will be kind of stored. So in the form of Tfstate file, right? So it stores in a file called what is it? Terraform.tfstate file, right? The entire infrastructure will be the, either we can able to kind of care that particular tfstate Terraform.tfstate file, or we can see Terraform show. So that show actually will give in the kind of JSON format, but Terraform Tfstate file will be in the kind of raw JSON format. So the Terraform show command will give the the proper order. Okay, the kind of the format will be the proper. Okay, okay. So there is also a backup file. Okay, so maybe if you come across, okay, so there are multiple. So there are two files will be there. So whenever first time when we apply the Terraform, when we do Terraform apply, right? So we'll be getting Terraform.tfstate file. So this is the remote state of our infrastructure, right? So there is also a file called backup. Okay, so that is Terraform.tfstate.backup. Okay, so when we execute the Terraform apply, right? So the command Terraform apply command, the new Terraform dot state tfstate file will be created. Okay, so and the backup, right? So the backup file will be will be created at the time of when we have a kind of second time when we do some modification, right? So that time the backup file will be created, and the new infrastructure, the new changes, whatever changes we are going to apply newly, so that will be the tfstate file, the current state. The backup will always be having the older version of the tfstate file. Okay, so always we'll be having two state files, tfstate files. One is just .tfstate file and .tfstate backup. Okay, these two files will be there. So .backup will be having a older version, and .tfstate will be having a newer version. Whenever we apply, the backup file will be having a duplicate copy of it. Okay, so this is how the Terraform keeps track of the remote state. Okay, if the remote state is changes, okay, so we are making some change in the remote state, and we are hitting kind of remote what the Terraform apply again. Okay, so what the Terraform will do is it will kind of make the changes and correct that particular change in the Terraform .tf state file. Okay, so whatever change in the what is it in the code. Okay, maybe provider.tf or variable.tf, we are making some change, right? So Terraform will make the same changes and meet that particular the remote state file, df state file up to date. Okay, take for example terminating an instance. Okay, so that is the instance has been kind of managed by the Terraform. Okay, and we are going to terminate it manually in the console. Okay, after when we run the Terraform apply, so it will start it again, because that particular instance has been maintained with the Terraform at the time of running the tf state file, right? So what was the status, so it will maintain the state. So it won't keep the state whatever we manually did. Okay, so that's how the Terraform will be maintaining it. Okay, so where this particular tf state file will be kind of stored. Okay, so we can keep this particular terraform.tf state file in version control, right? So version control. Okay, we'll be storing it into some repository, we call it as. Okay, so that repository is like git is the one of the repository. Okay, git is the one of the thing, or maybe s3 bucket. Okay, in Amazon we say s3 bucket, there also we can able to store it. Okay, so the multiple places, so git or s3 or any other repositories which is maintaining the version history, then we can make use of it. Okay, so it gives us a kind of complete history of our the Terraform state file. Okay, which is like a Terraform state file is like a big JSON file. Okay, so history means when this particular file is changed, and who has changed, and what is the actual change, and how many times that particular change has been, all those things kind of the whatever we do on this particular tf state file, then it will maintain everything. Okay, it will keep track of the changes, and it will maintain the history for each and every changes. It will maintain, like, first change will be in version 1. Okay, v1. Second change will be in the 2. The third change will be like, so it will like that. It will keep on kind of maintaining the with the history for that. Okay, and also and also, right, when we decide to go for this particular repository, the version control system, right, n number of people can able to work on this particular tf state file at the same time. Okay, so maybe the person one is coming here, and he is kind of using this particular Terraform state file and making his changes, and he is pushing that particular change into kind of git or s3. Okay, this is the person one, and person two at the same time person two also coming. Okay, and he also can able to have his local copy, and he can make some change, and whatever change he can able to do that, and that also can able to push it. Okay, so the Terraform kind of so this particular source control tool, right? So this will allow the particular team, right? So it will allow us to collaborate with multiple team members. Okay, so but we cannot have the same state file at the same time. We cannot be handled by two people. Okay, it will be kind of conflict. Okay, so we'll be getting the conflict when two people work on the same file at the same time. Okay, so but we can have a kind of local state file. Locally a person can have it, this person also can have it as a local copy. Okay, so he can maintain his own copy, he also can able to maintain his own copy. Okay, so to store it, we have to have a kind of some locking system. We cannot able to store it. Okay, right. So so there is a concept called backend. Okay, so there is a concept called backend functionality in Terraform. Okay, so what it will do is we can able to store this particular Terraform state. Maybe let's try to store it in a S3 bucket today. Okay, so how this particular Terraform state file we can able to push it to S3. Okay, so the by default there is a local backend which will be available in the Terraform state file. Okay, wherever we are running it, so that will be the default state file. So we have other backends like S3 is the one of the backend, and we have a console, right? So from console is from Apache, I think HashiCorp. Okay, console is another repository. Okay, and we have Terraform Enterprise. Okay, so it's kind of enterprise is a kind of commercially will be using it. So it's a commercial solution. Okay, so Terraform Enterprise or S3 or Console, HashiCorp Console or Terraform. So anything. So these are the backend services we are having it. So we can store this particular state file. Any of this. Okay, so I'll show you how to kind of store our this maybe just so using S3, so how to kind of push this particular TF state file or store this particular TF state file into S3. Okay, so not only TF state file, any kind of sensitive information or maybe kind of configure information or some access key, whatever, right? So SS key, SSH key. So all these things, if we want to store it somewhere, then maybe we can use any of these particular backend services. Okay, so we don't need to store it anywhere in the locally. So if we want to store it in the kind of some kind of secured places, then we can go for the backend services. Okay, so it's very simple to do this. So there are just two steps only. Okay, so one is like we just need to kind of add the backend service, backend code, something like that. Okay, in our .pf file, some Terraform file will create it backend from Terraform. Okay, and then just run the init process. So that's it. Okay, so this will be happen automatically. So let's try it out. Okay, so to configure, right? So maybe um, what is it, S3 and all. So what we can do is, let me connect the particular stuff machine. Go here and we give S3 here and go here S3. Let's create a bucket, some temporary bucket here. Either we can create a bucket from our Terraform code, or let's create manually now, and we can able to kind of how I am going to store that particular TF state file here. Okay, if you want to kind of make it automated way also is fine. Okay, that we'll do it later. So right now the scope of understanding is like how we are going to store TF state file into S3. Then later we'll be learning the S3 alone for some purpose. Okay, maybe I can say test what is it, backend S3, something like that. I can put. All right, so choose bucket, choose bucket. All right, it's optional. Okay, maybe I can enable versioning. Okay, so the reason why we are going for bucket is a repository. Okay, so repository means we are going to, it's a place where we can able to store the files. Okay, that is repository. But even directory also we can say it is a, or some portable hard disk also we can say it is a kind of a directory only. Then what is the difference, right? The difference is the repository will maintain the history, it will maintain the versioning. Okay, that is the reason we are going for repository. But other storage places it won't maintain, it's simply just kind of as a file system. Okay, so that is the reason we have just enabled versioning, bucket versioning. Okay, so create a bucket simply. Okay, bucket name is name already exists. Okay, some name is already existing anyway. Okay, this particular bucket name we are giving, right? So this should be globally unique. Okay, it should not kind of duplicate on any of these particular region. See, we have plenty of regions, right? So all these regions. So in any of this region, nobody has given this particular name. Okay, this name should be completely unique. Okay, maybe I can put the name April 11, something like that. So this will be a unique. Okay, create bucket. All right, so the bucket has been created. Okay, the bucket has been created. So inside this bucket, if you see, nothing will be there. Okay, so it's empty bucket. Okay, now in this particular bucket, we are going to put our TF state file. This is very important in production or any of our the kind of day-to-day activity, anything in Terraform, right? Even our source code also we can able to put it here. Okay, right. So let me create a sudo soup. Okay, super user. Super user is what sudo soup is about. Okay, now what I'm going to do is. Right. So let me create some backend service. Maybe I can say backend .tf, something I'm going to create. Okay. So for the backend, right? So what we'll be doing is, so this backend is going to use by Terraform. Okay. So I'm just giving Terraform. Terraform is going to use this particular backend service. I'm going to give backend. Okay. So which backend? So S3 is will be our backend, or we can give console. Okay. So for that and all. Okay, so let me give the bucket name. Bucket. Maybe what is the bucket name we have given? That we'll get it later. And we have to give the key. So key will be the path. Okay, so in which path this particular file has to be stored. Then region. Okay, so our region is US East 1. You can get it from here. Uh, that you can get it from here. Okay, North Virginia, and you can US East 1. Okay, in the top right. So the US East 1. So the key bucket name, what is the bucket name? Uh, okay, let me go here. And what is the bucket name? Bucket name is test backend April 11. There is a bucket name. Go here and paste it. And what is the key? Okay, so key maybe I can give maybe Terraform TFM slash my state state slash okay, let it be my state. Okay, my state file, something like that. Okay, so this is the key I am giving. So for this particular key only will be created under this particular bucket. Okay, so let me go here and save it. Okay, so So what I'm going to do now is like, so once we created a backend service, now what I just need to terraform terraform validate. Let me check it. Okay, it is saying why this particular. Okay, so the bracket is missing. Okay, so I need to perform init. So validate now. Okay, now it is success, right? So let me give apply directly. So when I apply, whatever the Tfstate file currently we are having, right? That particular Tfstate file we can able to see it here. Okay, so maybe I can refresh it and I'll show you. So it is no objects, right? Under this particular. So let me apply it now. Okay, apply completed quickly without. Okay, see, TFM is there. Okay, and my state file is there. When you click it, we can able to download it now. Now you see, okay, it is having the entire data, whatever data the TF file. Just go here and download. Okay, so the state file will be in the JSON format. Okay, so this is how we can able to store our we can able to store our the state files in our. Let me go here and just to open it. Okay, so right now the infrastructure, we don't have any infrastructure, so that is the reason everything is blank. Maybe what I can do is quickly, okay, so copy dot slash my environment dot slash. Um, Now Terraform. Okay, what I'm trying is I'm just giving some resource. Okay, so which we already done that, but since our state file is empty here, right? When I download, it was showing empty only, right? So for that, I'm just creating some resource so that. Okay, I'm going to create it. Apply now. So I just applied it. So when we apply, the instance will be created at the same time. That particular Terraform file also will be stored in S3. Okay, now we can able to see the S3 buckets content. The Tfstate file content. So it is created. Okay, I'm just refreshing it. go here S3 bucket, repress the bucket, and I get the Terraform, and again the Terraform my state key file, and I just go here download. If I download, it will be downloaded the JSON file. Now you see the actual Tfstate file will be here. Okay, let me go here. See here, we got the complete stuff. My EC2 is the instance it is created, so we are getting the actual instance state here. Okay, so whatever the Terraform state file, right? So it's a kind of backend.tf. So the same Terraform.tf file will be stored in the S3 bucket. It won't be available here. Okay, so from the backend only it will be taken forward. Clear, right? So what we have done now, it's very important actually. So in production and all.
Yes, yes. So every time you create a new instance or do any kind of a change,
Every time whenever you take any change, so the tf state file will be updated, and at the same time it will be stored in the S3 bucket. So we are not
there
maintaining
will
locally
be
here.
there will be multiple versions of Tfstate file, right?
Version will be maintained here. So you see versions. So there are two versions now. It will be, see, the first version will be like this, and second version will be like this. Okay, just click open. It will maintain what is the version of the first one. Okay, just download it. You will get it. Then go here, open it, and download it. You will get it. Okay, those versions will be maintained. Normally, right, TF state file and all, it will be part of our what is that IDE, integrated development environment. Some IDE tool will be there, so there only will be maintaining it. It's part of our project structure. Okay, but we deal it in a different way. So we don't deal this particular state because it's a runtime file. It is not a file which we create, right? It is created at the runtime by Terraform. So this will be treated in a different way. But in IDE, right? So in integrated development environment, all the TF files, whatever we are seeing here, right? So TF state file, backend TF, my TF, provider TF, all these are development files. Terraform actual code, Terraform code files. Okay. So, but Terraform, the state TF state file is not a code. It is a result. It's output, right? It's a infrastructure that is the actual output response of the particular code. If you run this particular code, we'll get that particular state file, right? So the state file is the actual one, actual thing. So that we are handling it in a different way. Okay, so for this and all, right? So we'll be storing it in our code commit or any kind of source Git repository, something like. Okay, so whenever we create EC2 instance, right, EC2 instance. So by default, right, so this will be automatically adds 8 GB, 8 GB of EBS, right, elastic block storage with that particular EC2 instance, right. So if you see here, see, we just finished doing that. The storage would be over here. The storage space would be 8 GB. Okay, so volume will be 8 GB. Okay, so by default, that is what it will allocate. Okay, there are two types of storage here. So one is the local storage. So whatever the EC2 instance will internally provide, that is kind of the local storage. Okay, so this is called, that particular local storage is called ephemeral storage. Okay, so that is called ephemeral storage. So the 8 GB is ephemeral storage. Okay, so ephemeral means it's temporary, right? Ephemeral storage. Temporary storage. So another one is kind of it's a root. Okay, it's a root volume. So that is like a slash, right? It's a root volume. Okay, root volume storage. Okay, so this storage can be exceeded. Okay, can extend from 8 to greater than 8 GB. Okay, so both will be having the same the volume only, but the root volume can be able to increase. And this is the local stuff. Okay, so both will be ephemeral. So ephemeral means, so when you restart the instance, when the EC2 instance is got restarted, this particular local storage and the remote volume, right? So everything will be vanished. So it won't be kind of persist. Okay, so but we could still instruct the AWS not to do kind of clean or kind of what is it, make that particular volume delete. Okay, so it's like for that, right? So we have to explicitly we need to give some instruction to the AWS to perform like make that particular volume as a persistent. Okay, in most cases, right, the 8 GB of data completely will be vanished, destroyed at the time of the machine when we reboot it. Okay, so that will happen automatically. Okay, so we can have extra volume other than 8 beyond 8 GB. Okay, maybe for storing some log files or some application related data if you want to store it, some real data, right? So into this particular instance. Okay, so maybe this instance if you are running some sensitive application, and that application will be emitting some logs, and that itself will be producing some real data. So for that and all, right, 8 GB won't be enough. So for that we can able to increase it. So here that elastic block storage, right? So can be added along with the particular root volume. Okay, so the Terraform will be kind of we can able to attach this particular the elastic volume into the EC2 instance, any EC2 instance. Okay, so let's see how to do that. Maybe I can type it quickly here. We will be having AWS instance as a okay, my instance, my EC2. Okay, so like this. Okay, here you see, so we'll be, maybe I can show it here. So now you see we have instance.tf. Okay, so I just already created it. um, uh, to to kind of proceed further in a faster way. Okay, so this is the one. Elastic, it's a new resource type. Okay, Elastic, what is it? AWS EBS volume. You can get it from the same Terraform console itself. The Terraform, the documentation page itself, the same thing. Okay, so we just named it the particular volume, and we are just specifying that 20 GB. Okay, so 20 GB is here. It's like a it's like a what is it? It's other than what is that, root volume. So root volume is 8 GB. So apart from root volume, we are also having 20 GB. So it will totally be 28 GB. So root volume will be in the slash, right? Slash. So that will be the root volume. So 8 GB will be allocated. But here this 20 GB will be a separate mount path. Okay, that we are going to give it. Okay, so the mount path we are going to see attaching it to the volume. So this is the path. Okay, for example, so to this path we are going to attach this particular 20 GB. Okay, so this also will be part of our instance, but it's a kind of we are extending to beyond the root volume. Okay, but this also still ephemeral. Assume that this particular volume also start with slash, right? The mount path is slash. Okay, so our root path also kind of slash only. So if root path gone when we restart the instance, right? So this also will be gone. Okay, so for that we have other word count. We will come to that later. So now we have this particular size. We can able to define it. At the same time, we can able to decide the type of volume. So it's like we have a GP2, GP3, and all these are SSDs, right? So it's kind of what is it? it's a general purpose, right? It's a general purpose SSD. So there are two types of the volumes are there are three types of volumes. They can take it here. So there are three types of volumes. One is SSD, and another one is HDD, our usual this thing, and our this one is kind of our previous generation. Maybe we call it as standard, a standard way of handling the volumes. Okay, so it's like a kind of magnetic discs. Okay, magnetic drives. Okay, so in SSD we have two types. That is, okay, a general purpose. Okay, general purpose SSD. Okay, the another one is provisional. Okay, provision SSD. Okay, so why we have this kind of segregations, SSD, HSD, all these things. So these are for how we are going to handling the data, whether in a higher speed or higher volume. So based on that, they have segregated. The volume type has been segregated in a way. Okay, to achieve high kind of high volume of input output per second. Okay, and high large volume of data and speed. Okay, based on that, we have a kind of the volume types. So general purpose SSD we have a GP2. So here only we have two types. So that is GP2 and GP3. Okay, so general purpose 2, general purpose 3. So general purpose 2 was before what we are using. Currently it is general purpose 3 type of volumes. Okay, so you have to learn the more on this thing. So what is this about internally? Okay, provision is all about IOPS, like how many input output operations should happen, right? So per second. So based on that, this particular volume has been designed. Okay, so based on that, this particular volume is completely about it has IO1, IO2, IO1, IO2. So based on the input output, IO2. So it has these two types. Okay, so maximum is like so it's maximum it has 64,000 IOPS. So per second, right? 64,000 input outputs can able to process using this particular volume of drives. Okay, so all these drives. So this is our hard disk, normal our usual way of file system, right? This does not have any kind of what is it? No IOPS, and but it is like Mbps, right? So megabytes per second, something like that. Okay, so the data how the internet speed. So we are calculating, right? So we're copying the data within the operating system between two disks, right? So it is completely based on the data size. It does not have any IOPS. Okay, it's not measured based on the system speed and all. Okay, so when we compare this HDD with STD, okay, so it's very low cost. So why I'm giving this instruction means, so you have to decide which type of volume you have to use it for your infrastructure. You cannot just like that. You cannot choose any type of what is that volume. So you have to go with some standard, whether it's a low cost or based on the speed or based on the volume of data. So how you are going to design the infrastructure. Okay, so that you have to get it from the stakeholders or maybe the product managers for the particular service. Okay, so this is more about throughput. Okay, throughput. All right. So previous generation is like standard means so it does not have no IOPS. What is that? No kind of throughput. Okay, so it's completely kind of it's a magnetic drives. Okay, so our usual it's like our hard disk, right? It's like that. So our portable hard disk, right? So something like that. Okay. So now we are using GP3. So GP3 is the very recently used in the market. Okay, so it has lot of promising statements in terms of handling the data. Okay, one is cost. Cost wise, it is charging very less, and IOPS is very promising, and also kind of throughput. Okay, it has all the promising statement, cost wise, IOPS, what is it, the speed and throughput, the handling volume of data. Okay, the volume wise, speed wise, cost wise, the GPS is more promising. Okay, so just for your note, maybe if you want, you can read more actually. So maybe you can get it from Amazon page. Maybe I'll take you there. What is it? This is volume, right? AWS volume types. Just type it there, then you will be getting it. So here, okay. So volume types, yeah, see here it is. Okay, so SSD means it's a solid state drives. Okay, it's a hard disk drive HDD and previous generation volumes. So these are the three types. Okay, so we have a GP2, GP3, and IO2, IO1, and IO. We have one more thing, block express. So so durability, and also based on that, based on the business requirement, we'll be choosing the appropriate the volume. Okay, so there's some more items. So just go through that and try to understand what is that. So this is hard disk having kind of cold HDD and throughput optimized HDD. Okay, so what is the difference? So you can able to get it actually. So yeah, so these things very important when you uh, design an infrastructure. All right, all right. Okay, so with maybe I can go with this like. Okay. So here the EC2 instance, right? So in the EC2 instance, we are creating a elastic block storage. So this is with this particular resource type, and we are setting a 20 GB as the external kind of extra volume. Okay. So the root volume is 8 GB, and the EBS elastic block storage is 20 GB. Okay, for the particular instance. Okay, let me run it. CD plus EBS. All right. Okay. Um, right. Okay, let me check what else needs to be. Okay, so we are defining that particular volume, and that particular volume we are going to attach it to this particular instance using another resource called volume attachment. Okay, so it has lot of properties. What is the attributes? So what is the volume ID and which instance ID we are going to match it. Okay, these are the two very important stuff. Okay, for to attach this particular stuff. Okay. Okay. Alright, this is the volume attachment. Yeah. So this is what which is the volume to which particular data volume mount path. So it is particular 20 GB is going to allocate it. So this is the mount path. Okay. It's a kind of user defined. Okay, based on the product requirement, you can able to change it. Clear, right? So these are the two stuff. It's very simple. EBS volume, size and type. That is these two important. Okay, here volume and instance ID. That's all. Okay, so let me run it. Okay. Terraform. Throwing some error. What is this? EBS volume. US East 28 does not exist. Invalid zone. US East 28. Okay, it's a zone only. US East zone. EBS volume cannot be attached. But it is saying zone US East 28. Is there any typo here? No, right? US East only. That is, does not exist. We say. Okay, that's what happened. Does not exist. All right. Okay. Maybe I'll check. Okay. So when we run this, right? So this particular volume will be attached to this particular instance. Okay. So by normally it won't be automatically created. Okay. So I need to do that. Okay. Let me fix it. Give me some time. It is not allowing. Okay, why we need route table association, right? So we have a two. Okay, maybe I'll come to that particular example. We have internet gateway, right? Okay, let me finish this particular concept. Maybe I'll come back in a while. Okay, so the instance is created. Maybe I need to get that particular IP to connect. Maybe I can get it from here. Maybe I can get it from here. So that let's try with uh, public IP. Okay, take the public IP of the particular instance. Okay, let's try to connect it. Let's fetch right my and my key 6 between 2 and this particular IP. Okay. Uh, okay. Mm, this is to make used
I think you gave the name host name as TFM, right?
host name.
Yeah, where it is you're typing Ubuntu, I think it's expecting the actual host name. Is it not TFM that you give?
That is the user, right? User. So host name is our IP here. So either we can give the DNS or we can give the public IP. So that we are giving the user. Okay. So now we are inside that particular what is that particular machine. Okay. So let me give sudo. Okay, so we are inside that particular stuff. Let me give df-h. Now you see. So the 8 GB, right? So 7.8 GB is allocated to the root volume, right? So XP data, right? So this particular thing is allocated to um, allocated for the slash. So that is a root volume. So this volume we will be kind of losing when the instance is terminated. This particular volume, okay? Because we don't specify that this needs to be kept after even after termination. Okay, so we are not specific, we are not kind of giving an instruction to the AWS. Okay, so where is the one which we created 20 GB, right? So we just created, right, EBS volume of 20 GB. So that is not we are not that is not appearing here, right? So what we have to do is first we have to create a file system on it. Okay, so then only then we have to mount it. Then then after mount it only we can able to see that particular stuff. Okay, so let me create some EBS what is that, some file system on it. Okay, so for that, right, so let me create make file system and make file system dot extended extended for
Okay,
basically
can we not
slash.
do these things using Terraform?
Say it again.
Uh, these manual
Terraform.
files, yeah, can we also do that, implement that using Terraform?
Yeah, so we can do that, but I'm going to map it manually in Terraform. Also what we have done is where can I show you? In Terraform we just defined it. Okay, so in Terraform they cat that particular stuff. Just a second, I will. Oh, not here. Okay, maybe let me control C cat instance. Okay, so here if you see we just attached it. Okay, so these things we can able to create it on the fly. Okay, so further we have a separate what is that, separate resources available called user data. Okay, we can run some script and we can able to create it. Okay, that we will do. Okay, so now the point is, right, so the volume we are creating, so for that volume how we are going to attach that particular volume for that particular the EBS. Okay, so for that particular instance, so we have a separate volume attachment, but on the fly also we can able to create this particular stuff. Okay, so that also possible. Now what I'm going to do is So let me make some file system extended for file system of slash dev. What is the one we created? Slash dev. All right. So the blocks, the particular is created. Okay. So now I'm going to create what is that? The particular EST file system, right? So and then I am going to mount it. Okay. Let me mount it. So let me create some directory for that slash data. Okay. So the data is created. Now let me mount it with our stuff.
Yes. Well, how do you know that was
This
the
we
device?
already configure, right? So here in our instance.tf file, we just already configure. For the same configuration, I'm just kind of creating it manually. Okay, so these things has to happen automatically in the Terraform code itself using the resource called file system resource. Okay, file system
And
module.
is the EC2 resource also in US East? Is that what you just changed in the mapping?
Correct. Yeah. So we are just mapping the volume of EC2 instance. The AWS instance we created, right? And it is having some ID. So that ID we are going to map it here. See the volume ID and the EC2 instance ID. The example
Okay.
EC2 instance. Okay, we are going to map it there. So now I mounted the particular path to this particular directory. So I am going to df-h. So the 20 GB will be available here. See, so we got the data. So the particular slash data will be available. Is available 20 GB. This is through completely through EBS volume.
Can this be done through user data?
Which one?
Can we do this through the user data option when the instance is starting
Can I
up?
do this? User data.
Mm-hmm.
Okay. So the reason we go, why we go for user data in, okay, so I'll come to that user data. Okay, so why we are going for that? Okay, now you think about, see, now wow, okay, this volume is not enough. All right, so whatever the root volume by default is offering, 8 GB is not enough. The one of the option is either we can increase this particular volume or we can have a external what is that extra volume like this, right? Using EBS. These are two ways, right? So but here also, but this also ephemeral and this also ephemeral because this particular volume, right, whatever the root volume is offering, that is slash, right? And this also, this particular volume also, see here it's starting with slash dev slash. So this also will be part of root volume. When we restart the instance, both will be disappear. Both, it is still not a kind of what is that a persistent. Okay, we are having a large volume, but it is not persistent. Still this is like a ephemeral only, right? So at this point, if you see, when we reboot the machine, this volume 20 GB volume also will be gone. The reason why we go for this particular partition always will be there, right? The 20 GB is dedicatedly allocated to this particular partition, but we are mapping to this particular mount path, and this path only all our kind of the infrastructure data or whatever application we are running inside the particular node, right? Everything will be put here only. When we restart the machine, then everything will be vanished. So we need to retain those things. But here in this case, kind of both are ephemeral, right? So both are it's not a persistent. Okay, both are temporary kind of storage. Okay, so if you want to to put this volume into a kind of persistent mode, right? So what we can do, we can put it into the F step, right? So file system, these things like what is it, vi etc slash F step, right? So there, if you make an entry for this particular stuff, then it can able to retain. So let me put it there. and what slash data, right? So we are going to mount it to slash data, and this file system is ext4 and defaults 0 and 0. You know the meaning for 0 and 0, right? So 1 2 3 4 5 and 6, so fifth and sixth element, right? So this for dump, taking the dump backup, so something will be there. So maybe for to know more about this, right? So you can give you can try like man page, man fstab. Okay, if you go here and just read about the second field, third field, fourth field, and yeah, fifth and sixth field is what we gave 0 and 0. Okay, this for dump, the file system dump. Okay, and sixth is for use to for what is that, file system check. Okay, should be specified in something. Okay, drive to be checked sequentially, something like that. Okay, so just go through this particular stuff to understand more about that particular thing. Right. Um, right. So now what I'm trying is like now we are inside this particular stuff. Uh, okay. So what I have to do? So I have to unmount the particular data first. So because we just mapped it to fstab, right? So unmount it, and again, what happened? The package.
It is U mount.
Okay, you mount. Okay, you mount. Okay. Then again mount it. Yeah, so just mount it. Okay. So now, yeah. So now the particular F step from the F step, right? So it will this particular will be taking it. Okay. So while mounting, so you remember, so when we do mount before, so we were giving the complete path. So to which data? So when we this time, right? So it's already taken from the what is that? This thing F step, which we already configured. So now if we reboot, right? So this particular data will be always available. Okay, so nothing will be kind of removed, but still there is a limit. This data also will be part of the root file system, right? So root file system itself is a it's a temporary storage, and if this goes, if this is vanished, then obviously this also won't be available, because this is comes under this particular root file system, right? So for that purpose only we are going for user data. Okay, so the point why we are going to user data is user data will be having kind of some set of scripts to run while launching the particular instance. Okay, it's kind of prerequisites. If you want to run something, if you want to set up something, kind of to launch before launching that particular instance, we can perform those set of steps using user data. Okay, we'll come to that later. Okay, so now we know how to kind of map, create the what is the EBS volume, and attach the EBS volume to the EC2 instance. Now after attaching also, the reason why we are going for attaching and having a volume is to store large amount of data. Since root file system is a ephemeral or kind of what is it, temporary storage, and we are going for the this particular stuff. Okay, the EBS volume. The difference, right? So the difference between the root file system and EBS volume is, in EBS volume we can have kind of some flag. Okay, so whether we should we want to delete it upon termination. Okay, those kind of flags we can able to set it. Okay, maybe you can try it out. It's like a root file system, right? Maybe, uh, okay, maybe here itself I can show you. Exit, uh, exit the VI instance. Okay. Here itself we can able to set it. Okay, in the EC2 instance. Um, so there is a new block called root block root underscore block underscore device. Okay, device. If you use this, this has a one of the attribute called whether should be delete on termination. So when we when the instance is terminated or we are kind of rebooting, right? So by default it is false. Okay, so if you want, make it is true. Okay, so true, and we can able to add some more items like what is the volume size, okay, the size of the volume and the type of the volume. So everything we can able to supply it here. Okay, but this particular stuff has a one more advantage. We have this particular flag, delete on termination, whether true or false. By default, it won't be available. Okay, but this particular EBS volume, right? EBS volume does not have that option. Okay, by default it will go, but here the root block we have this particular option. Okay, we have this particular choice to choose. Okay, whether we need to go for the terminal, the data should be deleted or not. Okay, all right. So we have this particular limitation in this particular the handling the particular volume, right? So that is the reason we go for user data. So user data will give us a kind of some workaround. Okay, it's like a EBS is like a snapshot, right? It's like a snapshot. So, but even though when we relaunch the particular instance, everything will be go out. Okay, so I want to retain that particular stuff forever whenever the instance is restarted. Okay, whenever the instance is launching, I need to execute some set of scripts. So for that we can go for user data. Okay, so the purpose of user data is, let me, okay, it's user data. So we have a separate block called user data under AWS instance. Okay, so under that we can able to give some script. Okay, so some command or whatever we want to execute. Okay, so bash script or some shell script, whatever we want to execute, we can able to give set of instructions there. Okay, so it is like maybe I can show you the particular code here. Okay, you know the purpose of route table, right? The
Sorry, say
purpose
that
of
again.
route table, no, the purpose of route table, why we are configuring that, you know, right? In the infrastructure.
Yes, yes, I know the purpose of it.
Okay,
For internet traffic and also for subnet traffics. So, but I was saying the TF file. I wanted to see the code, how the code was set up. The TF file for the route table is what I was trying to see.
okay. Can you show me the code? So I don't have the code. Maybe I can. I need to get it from the net only.
But I
So
saw
maybe
that
I
in
can.
your Terraform plan, Terraform apply just now. Did you copy it from the internet or something?
Yeah,
Did
yeah.
you
I
copy
copied from internet only. Yes.
from Terraform line for line?
You want me to search around in internet?
No, no, no. I saw I saw route table association. If you can just
Okay, association. Okay, all right.
if you open up the TF file where
Uh,
you put that in, what TF
sure,
file
sure.
is?
All right. Yeah, it's in VPC. Tell me. Yeah, there is a route table we are having.
Okay, so there's one for the public. So all you do is provide a subnet. I see. And then so there's public. Why three public subnets? Is that the default for the VPC?
No, no, no. So I didn't follow. So I just taken from the internet somewhere, just to show you that particular EBS volume. That's it. Uh, So this things are already you tried, right? So that's why I just didn't touch upon. Okay, so
Yeah.
creating subnet, creating VPC and subnets. So that exercise I gave you, right? So that this will cover everything. So it's quite straightforward. So what is there any doubt here? So we have a private subnet, we have a public subnet, right? So public subnet will be attached with the internet gateway. See now you see. So here in this example, they are having a multiple subnet, public subnets, 1, 2, 3, 1, 2, 3 public subnets, one private subnet they are having. So this private subnet will be attached with NAT gateway. We'll see that. Okay. So now here there are three public subnets. Name is public, public, public. Okay, and one private subnet. Let me go through this particular stuff. Okay, and two private and three private. Okay, there are three private subnets. Okay, okay. Internet gateway is created, and this particular internet gateway is okay, and route table is for public. Another route table association. Okay, for the okay the subnet public subnet. So for each and every public subnet, right? So they're mapping the route table. Clear? This is clear, right? This is clear, right? So the private subnet they are not doing anything.
So the
So the
route table
private
is that the attachment? Is that the attachment of
the
the I?
attachment is like subnet only.
No, what for the route table?
Subnet with route table.
Yeah, for the route table, is that the gateway attached to the VPC
Yeah,
at the top? No, the one before. Is that how we attach the gateway to the
correct.
VPC?
Yes, this is how we'll be associating it, right?
Okay, okay.
But
Well,
with route table with internet gateway, it will be like this. So internet gateway dot with particular internet gateway name on that particular route table.
so without
This
that
is
and without that route, even though you are
say it
even
again.
without this route, the internet traffic would not flow. Without this route table
Correct.
block.
Yeah. Without that, internet traffic won't through, right? So they're having a VPC. They're having a VPC. In that VPC, there are three subnets. 1, 2, 3 subnets of public subnets and three private subnets, right? So and these three public subnets having a one internet gateway, and they are having a one route table. Let me check. Route table is one only, right? Route table is one only. Correct. So one route table that is mapped with all the public stuff. Okay, and there is no route. There is no mapping route table mapping for the private stuff. Private stuff. And this particular internet gateway is pointing to this particular route table. So this is how it is. This is how they mapped it. This particular infrastructure. It is kind of dead end. So there is. It is not a kind of proper way of doing it. So it is. This particular private subnets are simply idle.
Is that did you
Okay.
just do the public subnets association with the IGW?
Yeah. So here I'll show you. Yeah. Here it is. So we have the internet gateway, which is mapped with particular
Yes.
VPC. So the
Hmm.
internet gateway will come into VPC.
That's like the
Now so
attachment, right? That's how you attach it.
yeah,
Okay.
correct.
And then
So this
the
particular
route.
route table is mapping with this particular internet gateway.
Okay. Oh, you're doing the same using the same route table for the public sub for the private subnets. Can you scroll down for the private subnets?
Yeah,
I
yeah.
see.
Private subnet is not associated with anything.
It's
They
not.
simply left it. It's not. Yeah.
Oh, see, so it's only public subnets that are associated. You scroll down. Any private subnets associations? None.
Yeah, we can have two-way, right? So either private subnet we can associate with this from this particular public any of this public subnet, or we can have a kind of some other NAT gateway from there we can able to do it. So
Oh,
either of this option.
so if I
So
had a
just it is,
bastion, if I had a bastion server which is in a public
yeah,
subnet,
Bastion will be this. This is the one. The okay. So Bastion they're not doing it. Maybe I can say this particular stuff, right? Uh, Let me take this particular stuff. So Bastion will be from here they will be taking it. So this is the boundary. So from here they will be taking a Bastion like this.
okay, associating with the public
Okay,
with the
for that, right, what you have to do is the subnet ID of what is that security group of this particular subnet, private subnets, will be a public security group. Simple. That's how the bastion will work.
Say that again, please. Say that one more time.
Say it again.
You said the ID of the private subnet will be associated with the ID of the public
No,
subnet.
security group. So security group level, you can able to do that. So based
Okay,
on the security group, now you see, if you manually if you try, so we'll get to know.
got you.
Maybe VPC.
Only for
Let
that
me
one
go.
host, right? Just that one host. Only that one bastion host will have that. Will allow that public sub will allow that.
Okay, let me create two subnets. One is private, one is public. If you want to implement the bastion kind of thing, and I'll go to private subnet. Okay, here itself something is there. Okay,
Just
maybe
don't
I'll
waste
go.
time. Don't waste time. Which one? Which
I'll
subnet?
show you here. Tell me. Tell me.
Which subnet will be associated in the security group for the bastion host? Is it the public? The bastion is already in the public subnet, so we're going to probably allow. We're going to add a rule for the private subnet in the security group of the bastion host, right? The rule will be allowing the
Correct.
private
So
subnet.
I got your point actually. So we have a private subnet, we have a public subnet to make it as a bastion kind of approach, right? So for the
Mhm.
private subnet, I'll open this particular stuff and I'll show you how the private subnet will be kind of getting the kind of jump server. See now this will be assigned as public subnet as its route table. Now you see. Let me create a subnet. Okay, so this will be my stuff. Here you can give the public subnet name. Right. You can just copy it, the public subnet name. Copy public subnet. This is how the jump server will work. Maybe I can create a new private subnet. That's all. So here instead of giving say either right, here if you give the public subnet of subnet name, then this will be the jump box, jump server, bastion server. Okay.
You're
So if
mapping
we
the private subnet to a public
yeah,
subnet.
yeah, mapping, right? It is quite simple. So let me show you.
Interesting.
AWS registry. There itself you can see the subnets. I will show you. Yeah, here instead of cider block you are giving, right? So that cider block will be the public subnet cider block. Simple. So whatever you are giving, yeah, if you give the public subnet cider block, then that will be what is that public subnet will be a bastion server. Okay, so instead of giving,
Okay. Instead of giving that subnet, you give the public subnet cider. Okay.
resource cider block, custom available design, map is there, private DNS, and we have association ID. Yeah, so the IP address, whatever you are giving here, right? So if you give public subnets IP address cider block, then obviously it is like a bastion. It's like a bastion. See,
So when
what you are
so
expecting.
private subnet is referencing the public subnet.
Correct. Yeah, that's how it is, right? So
Cider.
obviously, see, yeah,
So that way it can access, it can jump into all the private, it can jump into any private instance.
correct. So this
Okay.
will be our internet gateway. This will be having a route table, and this will be having this particular public subnet. And we are having a route table separate for private subnet. Now the restriction is like only whatever from the public to private, we are having a jump server, right? So whatever IP range cider block we mentioned for this particular public subnet, same thing you can mention it for this particular private as a target something. Okay, cider block, so that it will reach only these particular public cider blocks only can able to reach here. So that kind of restriction. So if you want to
Mhm.
reach here, only this particular IP range only can able to reach here. So that
Only this
restriction we can give it.
mhm.
Say
Only this
again.
IP
So you cannot
address.
give it in the route table level. You cannot supply it in the route table. You can supply it in the security group. Okay,
No, but you're
it's in the
creating the
security group
subnet.
level.
You're creating the
Yeah, it's a
subnet.
subnet level.
Okay.
Here, security group. See, I'll show you security group. Cider blocks, VPC ID, where will be. Yeah, see, it is saying anywhere, right? Anywhere, right? Egress this is, but ingress also we can give instead of AWS VPC main cider block. So here in the cider block, you can give it as a public security groups cider block. Okay, wait. Yeah, so not in the route table. Okay, so not in the route table, not in the subnet, only in the security group level you have to maintain it. You have to create it.
You,
Okay, not in
I
the.
don't want to. I don't want to take up. It's not fair for me to take up all the questions. I know others might have questions. Are you saying that it's best to associate it when you create the subnet, or add it at the security group level for the bastion host? Which way are you suggesting? You showed two methods. You said you can create the private subnet and associate a public subnet to the private subnet. Which one are you suggesting? Is it that method, or are you saying we should add a security group rule to the bastion host instance that would allow?
No, the best practice is go with the security group, not in the subnet level, security group level.
Okay, so that with
Why
bastion.
I mentioned subnet is like, so there also we have an option called to mention the cider block, but in security group also we have a cider block option. Okay, so it up to us where we need to mention the cider block of the public subnet, public.
Yes, because the subnet will be all instances. We only want just the bastion host to jump. We don't want everybody else we don't want everybody in the public subnet to jump. So it's more secure to use just to do it as the at the security group level, which is just that one bastion host that can jump to any private instance. I think that's more secure than to allow everybody in the public subnet to be able to jump into a private instance. That's wide open. I think just one instance, which would be at the security group level, we add that private subnet to allow outgoing traffic. And I think that's the thing, right?
Correct.
Is it an outgoing traffic? When we add the security group, it'll be an outgoing traffic, right?
Yes, yes.
When we add the security group rule, is it going to be an ingress or an egress? Which one is it going to be? When we add the private subnet to the security group, is it going to be an ingress or egress?
Now we have a separate security group for each, right? Public security group and private security group. We have a separate security group for each, public and private, right? We have two subnets. Two subnets also having a private public. Same thing like we have private sub public security group also.
So to allow traffic into from the bastion host to the private subnet, which security group would I change? Is it a public security group or private?
Okay, so from the private security group only you have to change. You have to map public security group CIDR block. Okay, you
Okay.
don't need to change anything in the public security group, but only in the private security group you have to map it as the incoming traffic is only public security group CIDR block. Simple. Today what we are going to do is like remote lock. So we know the use of the Terraform state file and Tfstate file. So this will be replicate our actual infrastructure, right? So here if you see, take any uh, Terraform code. So we'll be having a terraform.tfstate file. So if you do terraform show, so this will be the actual current state of the infrastructure, whatever we have implemented, whatever the resources we have created, and whatever the resource has been provisioned. So everything will be stored in the tfstate file. So now this tfstate file is available in our local repository, meaning that local file system. Now it's completely it's a local. So if we want to store it in the in some remote, right? So remote storage like S3 or console or in Kubernetes cluster or whatever, we have multiple resources, right? Maybe I can show you that what are the other options. Terraform, okay, so if you see here, so we'll be having multiple other options where we can store uh, our Tfstate flow. Okay, see we can have it as a locker. That's what currently we are doing it. Okay, so we have a console. We have OSS PG S3 bucket. We can store it in S3 bucket also. Okay, so we can able to see this what we have seen your class before. Okay, so how to create S3 bucket, now to provision it, this kind of provisioning. So creation is different. So for creation, we'll be having a AWS S3 resource. Okay, AWS underscore S3 underscore bucket resource. Okay, so those are the steps. Okay, so now this is currently available in the local. So if we want to move it to the remote, right? So for that we have to have a kind of some backend stuff. We can create one. V8 form something like that. I can create it. Maybe I can take something from here. Terraform is 3 years to the bucket. Maybe then make this picture. Uh, Key I can set the path to the key. Maybe bucket name we can give it as TFM um, remote state bucket, okay, bucket test, something like that I can do. And that is the bucket name we are going to create it. Okay, so either we can create it through code, through Terraform code, uh, or we can do it manually. So to create Terraform code, I'll show you how to do that. Okay, so key is the one where we can store our Terraform state file. Okay, so here we have to give the path, maybe Terraform hyphen state file directory something, then I can give Terraform Tfstate. Okay, the Terraform.tfstate file is the one which we are going to create under this particular directory, under this particular bucket. Okay, and this is the region we are going to use it. Okay, let me save it. Okay, now the objective is like tfstate file will be there. Tfstate file. Okay, so this is our machine, local machine. So whenever we do apply, so we'll be having that particular file. Tfstate file will be available local, right? So if you want to, yeah, if you want to keep this particular file in a remote, right? So the tfstate file we can keep it as a backend service. Okay, now this tfstate file is available in a centralized repository. Now user one is coming. Okay, user one is coming and going to run this particular tfstate file. Okay, so he can easily able to peacefully he can able to run it. At the same time, user two user two is coming going to use the same tfstate file, do it tf apply. Okay, Terraform apply, Terraform apply. Okay, so he is applying the stuff, and he is also applying the same time uh, when the user one is doing. Okay, so both of them applying the Terraform apply using that same tfstate file. So what will happen, right? So this tfstate file will be having a kind of same set of data, or maybe kind of different configuration. Whatever the user one is using, user two will be using. He may be using user one may be using a different configuration, like security groups will be different, and number of instances will maybe 10 instances, and and other resources may be different. Likewise for user two also will be the different set of infrastructure he will be using for the same tfstate file, and for the same location, whatever the location they have configured, right? Um, get Terraform. Okay, so here, whatever the same location, whatever we stored, right? So maybe multiple user will be having a different version. Okay, so that time how it will be applied. So when the user one is applied this particular configuration, at the same time if user two is using, so we have to acquire a lock. Okay, this particular uh, user will be getting a lock. Okay, so this user should not able to apply at the same time when this particular user one is using it, the particular file. Okay, so that is what we are going to see. So for that, right? So currently we are dealing with the particular tfstate file having in the local file system. Now we have to move it in the remote repository like S3. Okay, that is what we are going to achieve it now. For that, we have created a backend service like backend as S3. So like that, we can have other resources like PG and OS or Kubernetes, right? No console, all these things we can able to use it. Okay, so we defined a bucket name, and maybe we can create um, our own bucket name. So maybe you might have tried it, right? So to create a bucket name on your own, like like AWS bucket, right? So maybe right now, let me create uh, a bucket, S3 bucket. The bucket US is to one, and I can do enable versioning and all these things. We can even do it through Terraform code using AWS underscore S3 underscore bucket resource. Okay, yeah. So now I have created a bucket uh, manually. So this bucket is an empty bucket. It does not have any object inside it. Okay, once we run this particular, once we apply this one, right? So we'll be getting the Terraform state file will be stored in the S3 bucket. Okay, so now you see we have these two. We have these files, right? Cat EAP. So we have this particular string. It's a simple thing. So we have provider, and we are just creating an instance with this particular details. Okay, nothing else. And we have a Terraform code, Terraform for the backend service. These are the two services we are having it. Okay. And for this EC2 instance, we are going to create a tfstate file. Maybe what I can do is Terraform destroy. Let me do it. Okay, let me remove this backend is modified. So translation it. So let me try it. So whenever we do any modification on the backend S3, right? Not only backend S3 in the Terraform backend, the backend block, then we have to apply init. Okay, so that is very important. Okay, let me just try it so that I can show you the Terraform Tfstate file won't be stored in our local file system. Okay, now it is gone. Let me remove this tfstate file from here. Terraform.tfstate file and Terraform.tfstate file.backup. Okay, I'm just removing it from here. Okay, it is no more. So when I do Terraform apply it, so now we have created a bucket. Okay, so Terraform init we already have. So let me do Terraform apply. So once I apply, right, based on the configuration whatever we made here, so that particular Terraform tfstate file will be stored here. Hereafter. Okay, let's see. Okay, let me give S. So it will say instance will be created. Yeah. So once this is completed, right? So we can see that Terraform.tfstate file will not be created locally. Instead, it will be in the S3 bucket. Okay. So now we can able now we see Terraform state file is no more here. Okay. So it will be here. Let me refresh it here. So we can see that particular state file. See whatever the directory we have created here, right? So Terraform.tf file. So this is the key we have made. So Terraform state file directory. So it has put that. So under this directory, the Terraform tf state file will be there. So just go here. The tf state file will be maintained. So, okay, this is the first time initially we created the size everything, and whenever we just click it, we can able to download the current copy of it. Okay, and the version also will be maintained accordingly. So since we maintain this particular bucket as a this thing version maintained, right? So that's why it is creating. Okay, now yeah. So now what we can do is this particular state file is created, right? So once we are able to store that particular tf-state file remotely, now we can able to how do we lock it, right? So that now tf-state file is available here. So we need to lock it when multiple users are using this particular same state file, right? So um, okay, so to lock, right? So what we can do is the logic behind it, right? So we'll be creating a some what is that? Some table, okay? Some table in DynamoDB. DynamoDB. Okay, so DynamoDB will be having a table. So that table entry, right? So normally it will be having a kind of row and column, right? So it will be having kind of row and column kind of approach, right? So in that, the one of the column, right? The first column will be a lock ID. Okay, so lock ID by default will be created. So that is the primary key. That is the primary key for this whole table. Okay, so this table, once we create a table and we map this particular table into our particular S3 bucket, right? Then then the log will be acquired by the first user, whoever is using this particular bucket. Okay, it's kind of bucket level locking. Inside the bucket, we are ultimately we are referring this particular tf state file. Okay, and the tf state file log reference is maintained in the table, separate table, using the primary key called log id. Okay, so let's create a what is that table here. Okay, so let me go to AWS console, DynamoDB. So okay, let me create a table. Okay, all these things we can able to do it through code also. I'll show you at the end of this particular stuff. Okay, so all right, so now let me name it as
Uh,
um,
did you figure out the credentials yesterday? What was the problem?
what Charles?
The credentials are problem yesterday for when we're trying to do the TFT block.
Uh, Say it again.
The
I couldn't
TF
hear
state,
you.
the TF state block issue that we had yesterday. I mean, the
Yeah,
credential
TF
issue
state
we
file
had
lock
yesterday,
issue.
the credential issue we had. Did you? What was the issue with that?
Oh, yesterday what I faced, right? That one, right?
Yeah, what was the issue with that one? Yeah, what was the issue with the
Oh,
credentials?
okay. So the issue is in the same instance itself. So AWS configure, right? I configured with a different user. AWS configure, when we give the AWS CLI is running here, right? So AWS configure. At AWS credentials. So here, right? So I was configuring with a different user. So the user mismatch, it couldn't able to allow that particular resource to create it. So the
What
user
user
itself
was
is
that?
not available. Yeah, the
What
user
user is
itself
it?
is not available.
Oh,
Now I
you
was
mean
removing directly from the console itself. The console itself, I removed the user, and appropriate user key was mapped here. So that is the reason.
the user was what? Which user was it? Was it root or was it somebody in the pop?
What is that? User?
You're saying the user's credentials was different from root?
Correct. See here, we have IAM users and their roles, right? So here we have a user. So I had a set of users there. So I kept only one user and I removed rest of the users. So one of the user which I have deleted, right? So that user key was mapped here. So it was wrongly mapped. So it does not have any appropriate user to map in this console. So that is the
What
reason
was
the
the correct
resource was.
what was the correct user?
Yeah. So currently I have created a new user and generated the access key and mapped it here now.
Okay.
Okay, I recreated a user. I recreated a with new user and generated the access key and secret key and mapped it here.
Yeah, but we did that the last time with pop user.
No, it was 3 or 4 users it was there actually. So those users was not part of whatever the access key I mapped here. So it was mismatch actually between the user and the access key.
Okay.
Uh, yeah, that
All
was
right.
the issue.
Okay.
Okay, so right. So now the plan is right. So we are going to create a log based on the log reference key will be stored in the DynamoDB. And whenever the user is acquiring the is using this particular TF state file using this particular bucket, and the bucket will be internally referring this particular the table. Okay, the table is acquiring having the lock as a primary key. All right. So that is what we are going to see it now. Okay. So now, okay. So cat Terraform. Now you see we are having this particular bucket. Now in this bucket we are going to map that particular table. So for that I am going to create a table here. So just create a table, and I can give a Terraform remote um, that state file lock. Let's see here something. Okay, state file lock. Okay, here it is saying the partition key. So partition key is the primary key. Okay, so that is what we have to mention it here. Maybe what I can show is um, what is that, DynamoDB state locking. So now you will see, or maybe S3 bucket itself. Yeah, see, we have a DynamoDB state locking file. So here we have a table, right? So whenever we create a table, so we have to create a table with a partition key named as lock key. Okay, so with the type of string. If it is not configured, then it means that the lock is disabled. So whenever we create a table with this particular the column, right, this particular key, then it means that there is a key applied on this particular table. So whenever we refer this particular table on a particular resource, it means that the particular resource will be locked. Okay, so that is the point here. So I am just going here and mentioning the particular same lock ID here. Okay, so rest of the things, I think, yeah, rest of these are same. Okay, only the table name should be unique, and I'm giving a lock ID. So lock ID is the primary key, and I'm just going to go ahead and creating a table. Yeah, if the table name is unique, maybe it will be accepted. Okay, so the table is created. Now let me copy this particular table. Still creating. Okay, it is inactive state. Okay, let me go here and copy this particular table name. Copied it. So now what we can do is, let me go to Terraform.tfstate file. The same S3 bucket, right? So I'm going to apply this particular table to assign a lock. Okay, so for this, right? So we'll be using DynamoDB underscore table. The table name we are going to mention it. Okay, this is the table name. Okay, so whenever any resource is approaching particular S3 bucket, so and appropriate lock will be applied on this particular table. Okay, so to what is it, to use this particular service. Okay, so I just saved it, DynamoDB. Okay, all right. Okay, so now what I can do is like let me see. Terraform, maybe let me destroy it, then I'll apply it again. Okay, there is a change, right? And I can limit. Okay, backend is configured, so it is not leaving. So let me destroy the existing one so that I can apply it again. It's asking, right? So whenever we make some change in a backend block, then we have to do Terraform init. Okay, so all right. Okay, so this will be done. Okay, so now let me give Terraform init. Okay, so it will be initializing the provider. Then let me give Terraform apply. Yeah, okay. Now the first user is applying this particular stuff. Now parallelly, what I can do is, okay, let it be the same stuff. Uh, what I can do is, this is user. Okay, the same user, right? What I can do, let me create another user in IAM this thing, and if another user is trying to use the same Terraform state file, and we'll see how the lock is acquiring. Okay, so now this user does not having any lock issue, right? So now you see the another user is parallelly implementing the lock. Now what they're parallelly invoking the particular stuff, and we'll see. Let me create a new user, maybe user 3. Let me go here, and the Terraform stuff. Go here, just create a user. User is created. Go here, use credentials, and create access key, and the command line. I'm going to create next, create access. Okay. Um, Control V. Okay. So this user is created, right? So for the same user, um, what I can do is, um, okay, maybe for the EC2 instance, I can say EC2 instance. So now what we can do is, why it does not have any. See here, acquiring the lock. Okay, condition checking failed, or it is saying failed. Operation type normally. Okay, condition check failed. Condition check acquiring the state lock. We can disable lock. Okay, we can disable it, but the user is not accessible. Let me take the Tfstate file first because it's empty now. Let me create it once. Once it is created, it should be available in S3. So now I am going to apply again. Who is always boot on the okay. So what I can say is maybe I can give access key here itself. Okay, there is a change in this Terraform. Init we can't here. Okay. Maybe create it so that we'll be getting the same version of Tfstate file across multiple users. Once it's right, I'll be getting the latest of. So basically, we'll be having a that what is that S3 the Terraform S3 backend service, right? So we'll be having a separate for each and every user will be having a separate copy. So with that only it can able to differentiate which user is approaching Tfstate file. Okay, based on that it will differentiate. It's a different user, and it's a kind of then only you can able to understand the different users are approaching the Tfstate file. So based on that log will be acquired. Okay, so no Terraform.tf is what I am saying. So we have to provide access key. Let's see, I'm just trying it. Maybe okay. So
Can you just show me the architecture of what you're trying to do? Real quickly?
what else?
Did you draw out an architecture of what you're trying to accomplish? So you're trying to put the you're trying to log each user to access PSP file. Is that the goal here?
User? What is it? What else?
You're trying to map all the users that
Ah,
are accessing
correct,
the state file in the
correct,
DynamoDB, right? And
correct.
that's it's supposed to be for tracking. Is that correct?
This one. Okay, we are having a user mapping here for this particular service along with the table. Okay, what is the bracket you said?
You're trying to map all the users accessing the TF state file in the DynamoDB, right? So that you can know when to lock and when to unlock.
Yeah, yeah, that is true. But here, right? So here, since we it was saying the error is right. It's a conditional check failed. Okay, so it was saying who. Okay, it couldn't able to identify the different users. So that is the reason I'm just trying with the access key. So if that works, maybe I can try with without this option, access key and the secret key. Okay, so just to explore the other way. But this is not a right approach to give it here. Okay, so just to cross check why this particular error. Okay, it is mapping always root user. So,
Uh,
um,
should we not put the profile in there like default, so it knows
profile
who? Yeah, because you have profiles for each credential, right? Should we not put default in there to let
here
it
in
know?
AWS console.
No, 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 no. In the back end,
Okay, yeah, in the backend.
if we put the default in brackets to show that's what we want. You know what? You just ignore what I just said. You can try what you want. I would just
Yeah,
suggest.
I'm sorry, your voice is okay. It's too low at the same time.
Yeah,
Uh,
I'm on the phone. That's why.
Charan, can you rephrase it? Maybe I couldn't get clearly. I'm sorry. You said bracket, Charles. What is it?
No, don't worry about it. Just keep doing what you
I
do.
have a bucket. Okay, so bucket is there. So for this
No,
bucket,
if you do a cats dot aws
cat.
slash credentials, if you look at the credentials file in dot
Okay,
aws, yeah.
dot AWS and credentials. Yes.
Okay, so you see the default profile. You can have a
Right.
profile for multiple credentials. So I don't know if you're missing the
Yeah.
default.
Yeah. We can keep it here. But here, this default profile is not about not for root, right? It's not for root. So
So
for
that's why
sure
I'm
it
saying
is.
that if you put the default in your back end, I think you can put default and then the credentials in your back end as well to show which
Okay.
credential you actually want.
Okay.
Yep. So if you put that default in brackets inside the back end code,
Sure. Here you are saying, right, instead of new user, right?
we can put it inside the back end code. I think I saw it yesterday where you can specify the credential profile, which is identified by the brackets and the name of inside the bracket. No, yeah, it to be yeah. Why don't you Google it and you see put in AWS credential in backend in Terraform backend, and you see the syntax.
Okay, let me. You are saying okay, Terraform backend configuration. Let me go here and workspaces organization backend remote. Maybe we can give the so we can give it as a three. Yeah, so default backend is there. If the configuration includes no backend block, Terraform default to use the local backend. So yeah, by default it's using local backend only. Yeah, by default it is using local backend only. We don't explicitly set it here. If you are explicitly setting here, then that particular user will be taken. So I'm just ignoring the changes whatever we did. Okay, so I'm going with the same option whatever. So now where I was, okay, I just destroyed it. Now I have to rough before that. Let me check the yes init. Okay, Terraform init. Now apply. Now it has to report that particular Okay, it is still saying the root as the user. Error while acquiring the state lock file. Okay. Terraform acquires state lock file. It is error acquiring the state lock file. We have a different users, two users, and ID is lock ID is maintained in this particular DynamoDB. Go here, DynamoDB. The state file has come. In DynamoDB, it is fine, but it is not acquiring the lock. There is no table. Okay, we need to create a table. The table is not there. Extend here. So the table is not created. We created it. And what is the lock? For VPC peering. So if you want to communicate, establish communication between multiple VPCs. So let's take two VPCs. Like one VPC will be in 172.168.0.0/20. Okay, so another VPC will be 192.168.0.0/20. Okay, we have two VPCs. So now we need to apply kind of these two VPCs. Maybe what I am saying is like we need to create the peering between these two VPCs so that the instances which are running inside each VPC should be able to communicate each other through its private IP. Okay, so it's all private IP we are assuming, right? So through its private IP, through the peering channel, those instances needs to be communicated. Okay, so that can you just try it? Maybe I'll give you the kind of touch base on it, how to do that. Okay, so okay, so what we need is we need two VPCs. Okay, so with different cider range. Okay, create these two, and we need a subnet. Okay, we need subnet. We need EC2 instances, security group, and we need different key pairs, or key pairs maybe that will be the same. Or we can have a route tables we need, and lastly we have to do peering connection. Okay, peering connection. So what I'm requesting you to do is just create all these things through um, a Terraform code with your existing knowledge. Then I'll tell you how we can able to achieve it with peering connection, assigning the peering connection from the private IP through private API token. So we have to create a route rule there. Okay, so the route rule we have to give the policy like destination as a kind of the internet gateway, and this thing will be as a target will be as a this particular first VPC 1 to VPC 2. Okay, so maybe what I actually want is this is the first VPC and this is second VPC. Okay, so now we have what is that subnet here, and we have another subnet inside this particular VPC. Okay, so we have one instance inside it. For example, we have one instance inside this particular VPC, and we have another instance in this particular VPC. So now we have to establish this connection. Okay, so this is the connection we need to establish. So maybe I can say this particular connection needs to be established between these two VPCs. Okay, that is a peer connection. Okay, this is called peer connection, peering, peering connection. Okay, so once the peering connection is established, we have to have it as a these steps needs to be communicated. This stuff needs to be communicated through should be communicated from this particular subnet to this particular subnet needs to be communicated. Okay, so this communication should happen through its private IP. Okay, private IPs using its private IPs. Okay. Create a skeleton code of Terraform. Okay, skeleton code Terraform this thing. Okay, then later we will be applying on top of it. We will be applying the transit gateway. How we can make use of it. Okay, so that one we just go through that. Okay, the last class what we have seen is okay. So this is one of the item. The last class what we have seen is Terraform Tfstate file, how we can able to lock it at production site, right? So so all these things, right? So why we no need to worry if we are using Terraform cloud. So that's a Terraform itself is providing a concept called Terraform cloud. Okay, so Terraform cloud. It's kind of it's a SaaS product, software as a service product, which Terraform is HashiCorp is offering it. Okay, so if you want to manage TF state file, right? So we no need to have a kind of backend services like S3. So we create, right? We usually create backend services S3 and all, right? And we no need to implement for locking mechanism and all for TF state file. So everything will be taken care by Terraform core, Terraform cloud itself. Okay, so for that, right? So we need to create an account Terraform cloud. Okay, just create an account. Some sign into that particular cloud. Once you create an account, right? Okay, so this once you get the account, then we have to create a organization. Hmm, Let me go here. And, Okay, so it is asking to create a new organization. So organization means, right? So we can have a n number of workspaces. Normally, if you are not using, if you are using any other cloud-based stuff, right? So we have to create a workspace, right? In the Terraform code. Through Terraform code, we have to create our space. There, we need to have multiple resources for the each and every workspace. Then, so those segregation we ourselves needs to take care of it. But here, right? So in Terraform Cloud, if we take it as kind of create new organization under that organization, if we are creating a new workspace, so those things we can easily able to do it using Terraform Cloud. Okay, then we'll be creating the cloud backend services for the Terraform TF files. Then all the access key and what is that secret access key, everything we can able to do that. So basically, how it work is, um, basically how it work is, we have a set of Terraform code here. Okay, our Terraform code, and this particular Terraform code will be working on this particular. What is that? It's a Terraform CLI. Okay, there is a CLI, TF from CLI. Okay, and from the CLI we'll be invoking the Terraform cloud. Okay, Terraform. The actual Terraform code will be running on this particular cloud. That is the meaning. That is the meaning here. Terraform cloud. Okay, that actual code will be running here. Okay. to connectivity, right? To establish the connection, what we'll be using is, here we'll be using our access key. Okay, so here we'll be using API token. Okay, so I'll tell you how to create it. So we'll be using API token, and here we'll be using all our access keys. So access key and secret access key. Access key and secret access key. Okay, secret. Okay, we'll be creating all this. Then later we'll be doing all the Terraform init, apply, destroy everything. So everything will happen at the cloud end. Okay. So basically we are actually triggering it from here. So internally it will call the Terraform client and it will execute the Terraform this thing. So it will log in actually. So Terraform, using Terraform client only, we are logging in Terraform cloud. So to connect from our machine, right, our host to Terraform client, we have to use API token. Okay, API token. And from once it is reached Terraform client, through Terraform client only, we can able to use Terraform cloud. Okay, that account. So for that, we'll be using access keys. Okay. So maybe I'll tell you how to do that. So what we are doing is we are going to push our all our Terraform code via to Terraform cloud. Okay, so all our Terraform code is there, right? Our main.tf, variable.tf, output, some all the Terraform codes, we are going to push it to Terraform cloud via Terraform CLI. Okay, to connect this Terraform CLI, we'll be using API token. So all the Terraform code will be pushing to here. That is through API token. Okay, that's what I'm going to do it now. So for that, so we have to create a application instance. I'll go to it. So then from here, right? So Terraform Cloud, we can able to create all the resources, AWS resources, whatever resources, right? The instance, S3 bucket, or whatever, right? So we can able to create it. That is using access key. Okay. So let me get into. Okay, this is the Terraform Cloud. Okay, so we have to create a workspace here. So workspace is already there with default. Maybe I can say new organization. Okay, just or that's what I'm going to do. And the email. Okay, create organization. So this is already started. Okay, I think I have already created. Okay, so this is a project I'm currently we are having it. Okay, so this particular workspace. So under the organization, we'll be having a workspace. Okay. Um, this organization is the actual. Okay, so under this organization we have a workspace. Okay, so this workspace only will be connecting through CLI. Okay, it's a kind of CLI driven workflow. Okay, so what I can say is now let me create some file, Terraform Cloud something. Okay, let me create a main.tf. Okay, so it will be having some easy things inside, for example. I just go here, copy one from there. So if it is Terraform Cloud, we no need to create any backend services. Okay, the cloud Terraform Cloud will take care of because we are actually running the task there itself. Okay, so for that we no need to establish any community. Resource is AWS instance, STC2, and what else we have? It's AMI that will paste it and the instance. Let's go type. Yeah, that's right. Okay, so alright, so I have this particular stuff. Maybe I can have the provider also in the top. Provider is AWS. On the region US is we have simple provider and main thing. Okay, let me save it. Now, okay. Now what we can do is let's create some file, Terraform file. Okay, what I can say is Terraform backend. Um, backend. Okay, so now the point is here, right? The example it's output yeah backend. Okay, in the backend we'll be specifying the organization. So once we specify the organization from our Terraform code, it means that it will automatically connect the Terraform cloud and log into that, and it will take the workspace, whatever workspace we are seeing the bottom we are specifying, right, in this particular organization and this particular workspace. It means that organization is a higher level. Inside that we can have n number of workspace like development workspace, testing, right? So staging, pre-build, and production. So all these workspaces will be taken. So whatever workspace we are specifying, once the workspace is taken, and Terraform will kind of establish a communication from what is that Terraform cloud to access the services. Okay, so that's how it is. So from here it will access the services resources. What is that of AWS console? Then for that we need to have a what is that access key and a secret access key to make the connection. Okay, so for that, right, then we will be doing a Terraform init. Now you see what we are doing it here. So we have main. Let me create Terraform.tf. Okay. So this will be having our own desktop. Okay, Terraform and maybe workspace also. Let me copy this. See, we are having a multiple workspaces. See here, workspace is my app and my app prod. So this is my app dev, for example. Okay, so like that we can have in a single organization. Organization is same in both cases, but workspace is different. Okay, so we can have multiple workspaces. We can define. Okay, so our organization name is name of the org is, yeah, this is the one. Okay, my workspace, I would say um, workspace test. Okay, okay, so let me save it. All right, so I saved it. Now we need to establish the communication from our Terraform code to Terraform client. So that for that we need a API, all these things. Okay, let me do Terraform init now. Okay, before that let me check what is that. Okay, only these two steps. Terraform init. So required token could not be found. Run the following command to generate the token. Okay, so now it is prompting us to generate a token, right? Okay, so it means that we haven't established the communication between on the Terraform cloud and our local Terraform code, right? So we have a local Terraform code to Terraform cloud. We haven't established the communication. Okay, so for that, right? So what we have to do? Um, okay, so it says Terraform login. Alright, so yeah, so it is giving yes. So that it will use a particular backend and it will try to log in. Okay, so it is asking for the what is it, the token to generate. Okay, so we need to okay, so in the browser it has to generate the token. See this token. Okay, API tokens. Okay, go here. The procedure entry point script has could not be located in the dynamic link. It's not giving. Let me keep it aside. Okay, so now I need to generate a token. Just a second. So team token I need to generate it. So here I give s into the value for the AP token. Terraform will store the token plain text for the following URL. Yeah, so it has to be there, but it also should be there in the. Okay, maybe I can get it from here itself. Let me copy paste. Generated. Locator points. So let me do it. It's for 1 day, and let me get. So this token generated should be happen automatically, but it's not happening. All right. So let me copy this. Let me copy this and paste it here. Where in our this place. Okay, just enter. Yeah, so we got this particular stuff, right? So it is Terraform Cloud. Okay, we are new to Terraform Cloud, so instantly apply all the examples. Everything it is saying, right? So it is saying welcome, welcome Terraform Cloud. Okay, so now if I give Terraform init, this particular stuff will be running on the Terraform Cloud via Terraform client. Okay, so this is what we have done. Okay, so now we are doing Terraform. What is it? This command, we are running this particular command here. Okay, so that will be performing, executing on the Terraform cloud. So how this is happening through Terraform client via API token we connected, and from client to cloud. So access key and secret key will be used internally. Let me give init now. Okay, now we are completely segregating the code and the environment stuff. Okay, the real environment where it is going to apply. Okay, if I give Terraform apply, right? Terraform apply. Okay, so maybe we can give auto. Maybe let it go. Okay, so Terraform apply, right? So now the Terraform, the cloud, right? So in the page, we can able to see that the all the apply stuff will be happening there. Okay, let me go here. Fail to create configuration options was not found. The configure remote backend not found. So the remote backend is not found. Not found errors. The configure remote backend returns for not found. Let me try to do this. Not required. The remote. Okay, init. Reconfigure. do not exist, as well as resource the user does not have access to. User does not have access to. What user is okay? Maybe the access key is all right. So you apply to approve. Okay. Preparing the remote apply. Okay, so what we are trying to achieve is what are the command we are executing, right? So this thing actually applying on the cloud side. Okay, so that's what we are applying. So that is through Terraform Cloud. But it is saying remote backend returns error do not exist. Remote backend returns error. Why remote backend is already there? Terraform.tf we are having a remote backend and it is saying it's already there. Let me go here in the Terraform page. Where is the workspace? Workspaces test demo. Yeah, so 4 minutes ago, whatever we gave, right? Workspace test it is created. Okay, but not sure why it is. You see, workspace is created. Okay, so like that we'll be having a number of teams, right? Different teams will be there based on the different verticals will be there in a product, right? Each and every vertical will be having separate team name. So for each and every team we can assign the workspace and the same workspace will be created in the our organization under this organization. See, this particular workspace has been created, so they will be having their own set of Terraform codes and all. See, workspace example code is going right. Okay. Yeah, CLI driven runs. Okay, maybe it should be a not a cloud. It's saying it's getting. Let me try to Terraform destroy and see whether this is taking or not. Okay, so configuration itself is missing. Let me quickly troubleshoot it. Firstly, unable to find the remote state working on to the out of the loading XDNI. Receive message server remote computer. Okay, nothing related to so we are having a backend region is fine. Access denied. It is saying. Um, this is Here, once the workspace is created, inside this workspace, we have this particular workspace. 8 minutes ago. See, it's a workspace level locking. Okay, so earlier we did tried with the S3 storage, right? So here the lock control will be automatically applied. Okay, so that's how it is built. Okay, but there we explicitly created the lock control, locking mechanism. But here everything is implemented. Okay, credentials, Terraform Cloud is what we need to do. Backend is cloud. Okay, so there is no cloud. Maybe instead of backend. Migrating from to Terraform Cloud, okay, and apply. So the user does not have access to in addition to the resource that does not exist. If the user does not exist, please should be mentioned. Okay, preparing the remote apply. Running a Terraform Cloud output stream here, crossing the conversion cancel. Okay, stop stream. Hmm. Okay, so basically Terraform Cloud, whatever we build, right? So we'll be having a multiple environment here. So where is that workspace? The workspace. Yeah, we'll be having a multiple environment, multiple teams. So each team will be having their own workspace. Each workspace will be having their own set of TF files. Okay, so those TF files will be applied. Upon apply, we'll be getting a separate TF state file. So that state file will be stored on each workspace. So we'll be having a multiple TF state files. Okay, and those files will be placed on the multiple. What is it? This particular workspaces. Go to workspace. It will be having workspace. So this workspace will be having a TF file along with set of what the TF state file along with its set of TF files. Okay, so say for example we have a compute cloud. So all the compute cloud related service will be in the separate TF file. All the storage related service will be in the separate. So like that we will be having segregating all the all the resources. Okay, so for that we'll be creating a separate. Either we can create a separate workspace, or we can there itself we can able to categorize it. Okay, here in the workspace level. So each workspace will be having its own TF state file. But here it is created. What is that? The workspace is created, but it is saying not able to communicate with this resource. Configuration fail to create a configuration resource not. Okay. Yeah. Now wait, this simple stuff. Okay. Okay. Maybe I'll look into this. It is not working, but it is working partially by creating this particular stuff. AMA.tf. It's instance type is okay. AMA I haven't given. AMA I haven't given. Okay, this is something else actually. So Terraform Cloud, the API connectivity is fine, and the access token also will be fine. So preparing the remote only, remote apply. Okay, no, user does not have access to. Okay, I think the access permission from here to here it is not established. So this place is not happening from client to cloud. So yeah. Okay, the point why we are discussing this particular item is using Terraform Cloud, the TF state file will be handled in more effective way than what we are doing it manually. Okay, so in the other aspect. Okay, so in the kind of S3 bucket, whatever they are doing, right? So there we are explicitly setting that particular what is it backend and DynamoDB table, all those lock mechanism we are establishing it. But here in Terraform Cloud, this is inbuilt. Automatically it is applying it. Okay, so that is the point here. Actually. So this is more important. Maybe I look into this why it is not create. It is creating, but it is why it is not completing. Okay, failed to create some configuration version mismatch. I need to check it. Okay. Very quickly this so not one for the variable is not one. Yeah, so we are not able to get the relevant error. Yeah, I need to troubleshoot it. So yeah, give me some time. Maybe the next class I'll see. Along with that other items, the transit. What is it? Some merging stuff. Okay, so I'll check.
So we'll discuss about that VPC peering stuff. It's quite straightforward. Okay. Assume that same thing like the transit gateway. So transit gateway is like a transit gateway is like, see, from here there is one VPC, another one VPC, and we have another VPC and another VPC. Okay, so if these VPCs wants to communicate each other, we no need to establish connection like this. Okay, there are too many interconnectivity. Okay, instead of doing like this, what we are having is we'll be having a what is that, our transit gateway in between, and all these connectivities will be like this. Okay, so the to and fro will be happening from the transit gateway. Okay, but VPC peering, on the other hand, is quite only between these two. Okay, so only two, so not multiple, more than two VPCs. The peering won't happen. So peering will happen only between two VPCs. Okay, so now if we have a VPC peering in between, and this will be kind of establishing the communication between these two VPCs. Okay, assume that we have something in this particular VPC. We have some instance. Maybe yeah, some instance is running in the private or maybe the public subnet, and we have some instance, and here we have a some, maybe we can have it as a kind of private subnet, and we have some instance in this. Okay, so this particular instance needs to communicate, should be able to should be able to ping this particular instance with its private IP. Okay, with its private IP. But obviously, this particular subnet will be having internet gateway, right? Internet gateway will be there, and so this will be having a full access. From here, we should be able to access. So this will be a requester. Okay, so this will be a requester, and this will be acceptor. Okay, acceptor. Okay, so from the requester, it will try to ping that particular acceptor's IP of the private IP, should be able to pingable, or maybe able to, kind of connect through SH through VPC peering. Okay, All right. So we'll be having a set of cider ranges, cider blocks here. Here also we'll be having cider blocks, both sides. Okay. Same thing. So we'll be creating a VPC first. We'll be creating a subnet, and we'll be creating a route table. Then we'll be associating the route table with the subnet, and we'll be creating internet gateway, attaching this internet gateway with the VPC, and here this side also will be doing the both thing. Then all together we'll be creating a VPC peering. So in the VPC peering we'll be attaching requester and acceptor. That's it. So only these six steps. Okay. So creating a VPC creating, subnet will be creating, route table will be creating, associating subnet and a route table, and creating internet gateway, attaching the internet gateway with VPC. Right. Then this will be in the both sides. Then we'll be creating a peering connection. Okay. So this peering connection between the requester and acceptor. Right. So this is what we are going to create. So it's simple, right? So let me go here. Maybe I can show you how we can do it. Let me create two VPCs. Okay, maybe I can run it. It's simple, right? We already done many times. So creation of VPC, subnet, routing tables, internet gateways, attaching it, association, and routing policies. Maybe what I can do is yeah. So here, if you see, this what. So we have created a VPC. There are two VPCs. Okay, so based on how many, what is that, the regions, based on the number of regions, so it will be creating two VPCs, and we are creating a VPC connection. Then we are creating a subnet. Okay, it's a public subnet,
No,
and
no,
also we
wait
are
a minute.
creating a
Wait a minute. Where are you? What is var.list?
which one?
What is var.list?
Var.list is the in the variable we'll be having a list. We are maintaining a list. Okay. So there we are maintaining number of regions. Okay, see here, or at least we are maintaining the number of two number of VPCs. Here we are maintaining the number of VPC siders. Okay, so so this will be the first VPC name, and this will be the second VPC name. So we are going to create a two VPCs. Okay, and these two VPCs we are assigning different cider blocks based on this length of this particular list that will be created. Okay, so if we go here, yeah, we go here, so it will be taking the count as 2, right? It will be taking the count as 2. So based on that, it will be creating the number of VPCs. So even we can have a 2 AWS VPC resource, and we can create it separately. But here it's everything in the kind of parameters. Okay, it's in the
Count.index. Is it a lookup? Is it a loop or something?
yeah,
Is
it's
it
a
gonna
looping
loop?
on. Yeah, right,
So
right. It's a looping on.
is lookup a implicit loop?
No, okay. Lookup will be verifying whether it is existing or not. If it is existing, then it will be creating the index. Okay. So lookup will be mapping with this particular. This is the value, and this is the actual stuff which will be mapped. Okay. So we are having both map and list. So list will be having a number of VPC name, and this particular map is having a cider range. Okay. So it will be
So
taking the first
you
VPC, assign the first map cider value, second VPC, assign the second cider value with that. So that is a lookup. So lookup will be having a two values. It will be carrying the two values and assigning assigning one by one respectively.
let me put it this way.
Okay.
So let me put it this way. Um
This
let
is
me put it this way.
simplified
So
actually. So maybe
I
what?
know it's a key value pair, right? It's a key value pair. We never talked about the element function before. Can
Correct,
we look
correct.
what
Yeah,
what
it's
is
a,
the element function? How does it work in Terraform? Let me just see what it is in the documentation.
okay. Element, right? So element will be the index position. Okay, it's the element of first index position and
Okay.
element of second index position in the
If you
list.
go to the okay. So because of count is doing an implicit loop.
Yeah, it will be in the loop. Yes.
So okay, I get it now. So we're working from the back to the front. We get the first index, which is the this. It'll pass that. It takes lookup takes a map and then and then it'll pass that value to get the value. Okay. So it starts with the count makes it an implicit loop. I think that's what it is, right? When you put counts in any resource, it becomes an implicit loop for Terraform,
Right. Yes.
right?
Yeah.
So that puts the resource as an array. Interesting. I 01 to accept true. Okay. Okay. Awesome.
This we already seen, right? So your count and lookup, everything we have seen it
So
already.
lookup always takes the key, right? The key is what the lookup needs, and then to get the value from the map.
Right. So it will be trying to map the value, match the value. Okay. So assign the value. Take the first value and the first value of right hand
You
side.
mean the key?
Second
You
value.
take the first key, which is the requester, and the
Yeah.
value
So
will
the
be
key and
decided.
value. Yes.
Okay.
Okay. The same thing we'll be using the same count since we are creating two VPCs, two subnets, two route tables, right? So for everywhere, so we'll be creating the same count only. Okay, two subnets and wherever we use, right? So we'll be creating it. Yeah, yeah.
So
See
let's
here,
continue
we are
from here.
creating two security groups. So again, we are going to. Okay, all right. So now it's back to from the beginning. Okay, so we're getting a two VPC, and with the two VPC, we are going to create a VPC pairing. Okay, so the first VPC. Okay, so the create VPC of 0. So that will be the first VPC ID. Okay,
Yeah.
since it's a index based, right? So it's first
Mhm.
VPC and second VPC. Okay, that's how it will be. Okay. Then, okay, maybe I'll create it manually so that you can able to understand what is auto accept. Let me do it manually first. Okay, just create VPC. Maybe VPC1. We'll give some 10.0 dot or maybe 10.1.0.0 16. I just create a VPC. Okay, so this is a VPC1 I just created. Now again I am going to create another VPC. Okay, VPC1 is there. Maybe I can rename it as um, requester VPC. Okay, requester VPC. Requester VPC. Let me rename it. Then let me create another VPC as the start after VPC. This is 10.2.0.0. Okay. Now we created two VPC. Now we created two VPC. VPC1 and VPC2. Okay, now I'm going to create peer connection. Based on this particular code, right? We're going to create peering connection with these two VPCs. Okay, and I'll come to that pairing connection. Go to pairing connection, create pairing connection, and just give test peering connection. Okay, so see here, in this I need to choose two VPCs. That is, requester is the one VPC and
Wait, where did
acceptor
you
is the another VPC.
create the peering?
Is that right again?
Can you go back to where you started the create peering connection, please? VPC.
Okay,
I want to see
I
what
just
you did.
I just given a name for peering connection.
Now go to
Okay.
VPC again, please.
What?
VPC.
You want me to go back to VPC?
Mm-hmm.
Okay. Okay.
Okay, let's go to create pairing connections.
Okay. So here in the pairing connection. Okay. Create pairing connection.
Gotcha.
Yeah. So I'm just naming it test pairing connection. And there is a requester and acceptor. Okay. So requester will be our requester VPC. Okay. So some source and destination, left hand side and right hand side. So already it is there.
So
Right. And acceptor.
hold on. Select another VPC to pair with. Okay, so it could be a local VPC. What if I did another account? Click on another account. What would it say?
Yeah, it's simple, right? So just mention the another account that's it. It will be connected.
Click on another
It is
account.
straightforward. So mention the account ID
Okay.
and give the VPC acceptor. Then those things will be connected. Nothing. There is no change in the.
So scroll up for a second. Are we specifying why you didn't specify the second VPC?
Say it again.
Scroll up for a second. If you scroll up, select the local VPC to pair with. Okay, you specify the requester, you didn't specify the acceptor. You scroll down, you only use the requester, you didn't specify the acceptor. Are you
Yeah.
not going
So
to do
in
that?
this account only, we will be saying acceptor.
Okay.
That's it. So only these two we are going to choose it. So which is the source requester and acceptor based on particular port. This is the requester and this is the acceptor.
Yeah.
Okay, we have done that. So I'm going to create a VPC peering. So now VPC peering has been created. Okay, it has been created. Now the requester VPC is there, acceptor VPC is there. Okay, so it has to accept it. So to accept, just go here. Maybe I'll go back to here, peering connections. Okay, choose this. Okay, in the action, accept request, reject request, and delete peering connection, right? So we are going to accept the request. So by default, we are going to make it as accept request. See, it is saying pending request accepted. See here, pending acceptance. You can
Well,
accept or
let's be
reject
honest,
this
you
peering
you can
connection.
accept reject this very connection using the argument.
So we are going to accept it. So for that reason only, we are going to
You sure you want to
accept
say
the
you
request. So
request?
once it's accepted, right? So it is saying pending acceptance, right? So once
Mm-hmm.
it is accepted, then it will be ready. Status will be okay.
All right. Let's take a 10-minute break from now.
Yeah, it
I
is
need to
active
be
now. So this is why that is why we are giving accept equal to true for this particular peering connection.
that's
Okay,
correct.
now we are going to create a subnet. Okay, we are going to create a subnet.
Do me a
So this
favor, can
subnet
you
is
explain that line that says count equal to index? Whenever you have count, it's an implicit loop, right? In
yeah, it will
Terraform.
be in the loop here. Yeah, yeah.
So what it's
So
saying
we
is
are
that when
creating a
the first time they loop, it will use this one, the other time it will use this. So the first time, so only one instance will have an IP, will have a public IP, and only one instance will be in 2A. The first instance will be in 2A. This first instance will, the first subnet will be in
now here in this
AZ2A.
case both
The,
both subnets will be the public IP. Yeah, so it will be
no,
the
it's
last
saying that
step.
the second one is
It
false.
is saying false.
It's saying
Yeah,
the
it
second
is
one is
false.
false.